Dr. Lustig, welcome back to the podcast. As you know, I'm a huge fan, so is our audience, so I'd love to jump right in. One of the top comments that we got from our last interview together is a lot of people got motivated to want to significantly cut down on added sugar in their diet. And one of the questions that came up that I promised to ask you is that if I took this seriously and followed your recommendations and significantly cut down on sugar inside of the diet, what do you think I could expect to happen in a 30-day period of time? So I'd love you to start off on that.
Wow. Okay, Dhru. All right. First of all, thank you. It's my delight to be back with you. We travel in the same circles, and I just saw you 6 months ago in Topanga Canyon. Lots of fun. All right, to the point. What can you expect in 30 days? First 7 days, you can expect sheer hell. That's the first thing.
Sheer hell. Just so everybody's clear. Hell.
Sheer hell. And the reason is because of sugar withdrawal. So sugar, that fructose molecule, that sweet molecule in sugar that I rail against routinely because it is metabolized differently from glucose, that molecule is addictive. In fact, anything that stimulates the reward center in the brain, the nucleus accumbens, in the extreme, is addictive. So we have chemical addictions like cocaine, heroin, nicotine, alcohol, sugar. And we also have behavioral addictions, shopping, gambling, internet gaming, social media, pornography. There's an aholic after each one of those. Chocoholic, sexaholic, alcoholic, shopaholic, etc. Right? Well, there's sugarholic. And it's really easy to figure out if you're a sugar addict. All you have to do is ask yourself, have you ever said the following statement? Oh, I have a horrible sweet tooth. If you have, you are a sugar addict until proven otherwise. Now, if you're an addict and you go cold turkey off your drug of choice or behavior of choice, how are you going to feel? Dopamine is way down. Those dopamine receptors have been down-regulated like crazy. Okay? And maybe those dopamine secreting neurons have actually started to die because of the excitation. So it's possible that you can't even generate enough of a dopamine response. And so when you take the substrate away and you can't generate much of a dopamine response, how are you going to feel? Crappy, tired, irritable, don't want to get out of bed, certainly don't want to exercise, and hungry. And so until those dopamine receptors repopulate, and it can take up to 3 weeks for them to repopulate, you're not going to feel so good. And we've learned this by taking care of enough kids with sugar addiction to tell the parents what to expect so that they can tell the teachers what to expect. And the most amazing thing is after 5 to 7 days, it's like the fever breaks, like the kids come out of it and they go, whoa, life is good. And they're less belligerent, they're less irritable, they can study at school, they can do their homework, they don't cause trouble in class, they don't cause trouble at home. And the parents notice, and it's remarkable. And it's the first thing they come back and say to us that, I've got my kid back, because they didn't realize that what they had was an addict. So this is true for adults too. The first 7 days, you're not going to feel so good. After that, sky opens up, the cartoons, and everything is, blue skies after that, as long as you don't fall backward. Now, unfortunately, because it's addiction, there is this tendency to relapse. And because it's sugar addiction, and there's sugar in everything that's ultra processed, because that's what the food industry did on purpose, because that's how they hooked you in the first place, it's really easy to fall off the wagon because the substrate is always there. For alcohol, you have to go search for it. For cocaine, for heroin, you have to go search for the pusher. For sugar, the pusher is your grandma.
Yeah, it certainly is pervasive. And I guess the follow-up question that I'd have to that is, you and other people in your field have talked about how anybody who turns around nutritional packaging and looks at the label will see that there's recommendations for dietary fat. There's percentage daily recommendations for, other things like sodium that are on the label, but there's none for sugar.
Right.
Right.
And that's on purpose.
Maybe you could talk a little bit about that, but also when we're talking about significantly cutting sugar from the diet, what are we talking about is generally regarded as a safe level for people to be having on a daily basis?
Right. All good questions. So I'm going to tell you a little story. In 2011, I was at a meeting of the Culinary Institute of America in San Antonio, and it was called Healthy Kids, Healthy Flavors. And this was the meeting where the USDA and the White House, the Obama White House, had made the investment after the Healthy Hunger-Free Kids Act of 2010 to go all in on school salad bars. I called it Little Horror of Salad Bars. That meeting.
Was this Michelle Obama's campaign that she was part of?
Well, hers was Let's Move.
Okay,
and this
right.
was, the outgrowth of that. And in fact, the person who ran Michelle Obama's Let's Move campaign, Sam Katz.
Yeah, Sam Katz, the chef. He was the chef at the time.
Who was a chef for the Obamas in Chicago, came with them to D.C., and was the White House chef there, and also spearheaded the Let's Move campaign, who, by the way, is a very nice guy, and I like him very much. And I'm, and he's got a really, really cute wife named Alex Wagner on TV. And I see him at meetings and stuff, and I just saw him a couple of weeks ago, in fact. But he said something that at that meeting that just sort of blew my socks off in a bad way. I said, why was there no upper limit for sugar? Why on the nutrition facts label, when you look at sugars, there's no percent daily value listed? And he said, why would you need a daily value for something that is not a nutrient? And I went, whoa. Really? Not a nutrient. That's right. You got that right, Sam. I agree. It is not a nutrient because aside from energy, it doesn't supply anything. And there's no cell in the body. In fact, there's no cell in any vertebrate that requires dietary sugar, that requires fructose. It is a completely vestigial compound for human and vertebrate consumption. So, in fact, it is not a nutrient because it doesn't supply anything that you need. I mean, what's the definition of nutrient? Something you need in order to be able to either burn or grow or survive. Well, sugar doesn't meet any of those.
You're saying specifically fructose.
Specifically fructose.
Not the sugar that is broken down from carbohydrates in
Well,
the diet.
You don't need that either.
You're saying it's not an essential macronutrient like there's essential fatty acids.
Well, in fact, carbohydrate's not essential either. And
right,
the reason is
saying.
Because you don't have to consume it. Your body makes it. So there are these two processes in the liver, one that turns protein into glucose, one that turns fat into glucose. Glucose is so important that if you don't consume it, your body makes it. That's how important it is. So you don't need to consume dietary glucose. You don't need to consume carbohydrate. The Inuit, for thousands of years, lived at the North Pole. There's no place to grow a carbohydrate. They didn't know what a carbohydrate was. They had whale blubber. Well, the protein in the whale blubber got turned into glucose in the liver. The fat in the whale blubber got turned into glucose in the liver. And so they still had a serum glucose. William Stephenson, the famous Arctic explorer who got stuck in the Yukon, in 1916, prior to our entering World War I, and he lived amongst the Inuit for 2 years. And by the way, he found that the Inuit didn't have any cancer. And he wrote a book called Cancer, a Disease of Civilization. It was the first environmental discovery that cancer was related to our modern society, was Stephenson's recognition of that. He didn't have any glucose to eat for those 2 years, but he still had a serum glucose level. And he and his partner on the expedition ultimately checked themselves into NYU Bellevue in 1926, and for 1 year ate nothing but meat for 1 year. And it turned out they were healthier than the investigators.
And just to be clear, it's not that you're advocating this, you're giving us an example.
An example.
You're trying to help us understand
I am not advocating
the essential role or non-essential role of sugar and carbohydrates inside of the body, and that the body can actually survive.
That's right. So it is true your body burns glucose. That is true. And it is true that if you consume glucose, your body will either burn it or store it, and it will have a choice. But for fructose, it's completely irrelevant. Yes, we have a limited capacity to metabolize fructose, in the same way we have a limited capacity to metabolize alcohol. Now, who would call alcohol a food? Any dietitian on the planet?
People tried for a long time, right?
Yeah, well, indeed. And how'd that work out for us?
Yeah.
Not so hot. All right. The point is that alcohol has a caloric equivalent. Alcohol is 7 calories per gram if you burn it in a bomb calorimeter. Okay, well, fructose has a caloric equivalent too of 4 calories per gram if you burn it in a bomb calorimeter. Guess what? Trans fats have a caloric equivalent. They liberate 9 calories per gram if you burn it in a bomb calorimeter. We are not bomb calorimeters. We do not explode our food. We metabolize it. And we do it through specific biochemical pathways that have absolutely nothing to do with the amount of heat generated. Now, it just so happens that we do generate heat, but it also happens that over the last 150 years in America, our body temperature has gone down by 1.5 degrees Fahrenheit.
Across the population on an individual internal body temperature.
Internal body temperature has gone down by 1.5 degrees Fahrenheit. Now, how the hell do you explain that? Because of glucose? Because of fructose? No. The fact of the matter is our mitochondria are broken because that's where the heat comes from. So mitochondria are about 40% efficient. That is, they will turn about 40% of the calories that are presented to them into ATP, and about 60% will be dissipated as heat. So if you are reducing your body temperature by 1.5 degrees Fahrenheit, that means you are creating less heat, which means your mitochondria are not working as well as they used to. And so the question is, why is that? What's happened to our mitochondria? Now, just a month ago, you had Tom Seyfried on your show. And while I agree with 95% of what Dr. Seyfried talked about, I don't necessarily agree that cancer doesn't have a genetic component. But he did say that it's about the mitochondria, and I agree with that. Ultimately, cancer cells don't need mitochondria. Cancer cells don't even have functioning mitochondria. Cancer cells ferment and they generate the ATP based on something that doesn't need oxygen. Well, in order to burn calories, you have to have oxygen. But in order to generate ATP, you don't have to have oxygen.
Yeah, that was fascinating when I heard that.
Absolutely. That was why Otto Warburg won the Nobel Prize, was he figured out that cancer cells don't need oxygen to grow. The point is they do need a biochemical pathway. And that biochemical pathway has nothing to do with calories. So a calorie is not a calorie. And we have a limited capacity to metabolize the fructose molecule inside our mitochondria, having nothing to do with calories. Our mitochondria are very good at burning glucose. They are not very good at burning fructose, despite the fact that glucose and fructose have the same caloric equivalent of 4 calories per gram. If it was only about the calories, then glucose and fructose would be equal in terms of how the mitochondria would handle them. But they are not. This has been shown 50 ways from Sunday, most recently by Samir Softic working in Ron Kahn's lab at Joslin. Because fructose inhibits 3 central enzymes necessary for normal mitochondrial function.
And before you get into that, just to put a little bit of a pillar in the conversation that we're having right now, you're not talking about whole fruit as a healthy part of a diet. You're talking about large concentrations of added fructose, primarily, sugar sweetened beverages that are out there as a form of ultra processed foods in our diet. Is that correct?
I am talking about fructose beyond our mitochondria's capacity to metabolize it.
So a level that is beyond a whole foods diet.
That's correct. Well, remember that a whole foods diet has some fructose in it. Yes, fruit has fructose in it. I agree. Yes, it does. The question is, who's that fructose for? When you eat a piece of fruit, when you eat an orange, is that fructose for you? And the answer is no, it's not. It is not for you. And the reason it's not for you is because the fiber in that orange, unless of course you juiced it, but if you didn't, the fiber in that orange sets up a matrix, a gel, on the inside of your duodenum. The insoluble fiber forms the lattice work of the gel, like a fishnet. The soluble fiber, the pectins and the inulin, like what holds jelly together, plug the holes in the fishnet. And together, those two, the soluble and insoluble fiber that is found in an orange, will form a secondary barrier on the inside of the duodenum. You can actually see it on electron microscopy.
And you call it the duodenum?
Duodenum.
Duodenum.
That's the first part of the intestine after the stomach.
Okay, got it.
And that's where a lot of the simple sugars get absorbed. Now, you don't want to be absorbing simple sugars in your duodenum. You want them to go further down the intestine to the second part, called the jejunum. And the jejunum is where the bacteria are, the microbiome. So when you consume that piece of fruit, that orange, the fiber is preventing early absorption. So you don't get that glucose or fructose rise. And so therefore your liver never has to process it. Your liver stays healthy. You stay below your capacity to metabolize that fructose. So you stay below your threshold. And because you didn't metabolize it, since you didn't absorb it early, it goes further down the intestine, and the microbiome chews it up for its purposes. So you actually fed your gut. So you protected your liver, and you fed your gut, all because of the fiber in the fruit. So what I always told my patients was, when nature made the poison, it packaged it with the antidote. The fiber means that that sugar was not for you. It was for your microbiome. So we shouldn't even count it in terms of the, quote, calories in, because it wasn't for you. In fact, 25 to 30% of all the food you eat goes to the microbiome to keep those bacteria happy, healthy, and complacent. And when you don't feed them, that's when all hell breaks loose. And that's when you start getting all the diseases of chronic metabolic disease, all of the diseases of intestinal inflammatory disease, because the microbiome has basically taken over your intestine.
Just a clarifying point to connect two things that you've talked about, right? So you're talking about the Inuit and their diet,
Yep.
and they were primarily sustaining on not really having any forms of carbohydrate inside of their diet.
Right.
So what happened to them? You know, you were mentioning they didn't have
Right.
cancer, other things.
Right.
Did they have all these?
And they didn't have fiber either.
And they didn't have fiber. So is
Right.
that sort of a case that there might be, you know, the human body is quite adaptive, and whether you look at the Tarahumara tribe that's, you know, running in, you know, Central America and Mexico and are descendants of the Aztec, and they have 80% of their diet comes from carbohydrates. So you have the Inuit who have 0% or maybe 1% come from carbohydrates.
Right.
That the human body is quite adaptive as long as it's
Absolutely.
eating whole foods.
Absolutely. I couldn't agree more, Dhru. In fact, there are multiple types of diets that work. Okay. All the indigenous cultural diets that, human existence grew up on, they all worked. It's only the Western diet that doesn't. So if you're a gatherer and you're getting your energy primarily from carbohydrate, you are also consuming it with the requisite fiber in order to basically keep the microbiome healthy, because the fiber is the food for the bacteria.
We're not having large amounts of refined carbohydrates
Exactly.
in our traditional diets.
Almost no traditional diet has large amounts of refined carbohydrate. The closest would be the Japanese, because they had a lot of white polished rice. But they also had a lot of fermented vegetables too.
Mm-hmm.
So they made up for it in other ways. All right. Now, you also have the carnivores, the Inuit and, people on, the ketogenic diet. Now, you can still have green vegetables on a ketogenic diet and you can still get your fiber. But there are a lot of people who are like straight carnivores and they're fine too. So how come if they're not consuming fiber? And the answer is because they're consuming the other things that those bacteria need that basically ultimately feed them. So they are consuming a lot of amino acids. Those amino acids will ultimately be turned into short-chain fatty acids. Those short-chain fatty acids are food for the bacteria as well. So ultimately, the goal is feed your gut. And you can feed it one of two ways. You can feed it with fiber, or you can feed it with the stuff of meat and what's on a ketogenic diet, milk too. The one thing that you can't do is feed it fructose.
Now, you and I were chatting a little bit beforehand, and we were talking about Dr. Rick Johnson being on the podcast and my interview with him, and he did a whole deep dive into fructose and its relationship potentially with Alzheimer's that they're seeing.
Right.
And he put out a paper with Dr. Dale Bredesen, and who will be coming out on the podcast, is also a big fan of yours, and also David Perlmutter. One of the things that he was saying is that large amounts of glucose in the body can also get turned into fructose.
Right.
So you are still concerned about a lot of sugar in the diet that is coming from glucose. Is that fair to say? And do you subscribe to that idea that a lot of glucose in the diet could also be troubling?
So this is something I learned from Rick. And I credit him with this. I didn't know that glucose could get turned into fructose in the body until Rick Johnson. Now I understand that. And I've actually seen that in multiple papers and seen how, in fact, glucose gets turned into fructose, especially in the brain. Right. In the brain of pregnant women, in the brain of pregnant women with diabetes, especially.
Why pregnant women?
Insulin resistance.
Insulin resistance, that they're already
because
predisposed.
Pregnancy is insulin resistance. That's why.
Yeah.
And that's on purpose because you have to gain weight in order to maintain the pregnancy. Mm-hmm. So pregnancy is an insulin resistant state. Estrogen is an insulin resistant hormone.
Which is why they're so worried about gestational diabetes,
exactly.
preeclampsia for a lot of women, because your body's already inducing that state
on purpose.
Because you're trying to grow a human being. I think I heard from Ben Bickman that there's one other time in a human being's life where your body is inducing insulin resistance.
Puberty and pregnancy.
Puberty and pregnancy.
Those are the two. And they're both necessary for survival of the species.
High growth states.
If you were not insulin resistant during puberty and pregnancy, how would you gain the weight to be able to do puberty and pregnancy? It's required. If your leptin, the hormone that goes from your fat cell to your brain and tells your brain you've eaten, if your leptin worked right all the time, you wouldn't gain the weight. You'd be the 97-pound weakling on the beach, not able to put on any weight. But you have to gain the weight in order to induce puberty. You have to gain the weight in order to induce and maintain pregnancy.
All goes back to this larger idea that the body does most things on purpose. And obviously we live in a day and age where ultra-processed foods and excess calories that come from them, not that calories are the full story, but in this particular context, a lot of calories, a lot of energy coming from ultra-processed foods has put people in a position where they're insulin resistant all the time.
Exactly.
And now we have the byproduct of chronic disease that we're all dealing with.
Right. So the key that brings all this together, and this is work that I did back in 2006 and published a paper on it back then. The key to this is we have this thing called insulin, which stores energy, and we have this thing called leptin, which tells us not to store any more energy because we have enough. What's the relationship between those two hormones, insulin and leptin? Turns out that's the whole, enchilada of obesity, as it were. Understanding the relationship between insulin and leptin. And I will just state it straight up. Insulin is an endogenous leptin antagonist. Insulin blocks leptin signaling.
So the hormone that makes you feel like you're not hungry gets blocked when your insulin is high.
Exactly right. And it actually makes sense that that would be the case, because if you're trying to gain weight, you have to do it at two places. You have to do it at the fat cell. Insulin drives the energy into the fat cell to grow it. And you also have to do it at the brain to basically block the sense of fullness so that you will eat more in order to be able to keep the process going. So insulin works at the peripheral level to store energy, and it works at the central level to make you eat more energy. Insulin is an endogenous leptin antagonist. Insulin is the bad guy in this story. More insulin, more fat.
When it's out of control.
Right. Well, you need insulin. If you don't have insulin, then you have type 1 diabetes, and you won't be long for this world unless you get insulin shots. Okay, you must have insulin, but you want the least amount of insulin that will do the job.
Right. The Goldilocks component.
Exactly.
We don't want too little. We don't want too much. We need the right amount that doesn't cause excessive damage from being inside of the body.
Right. Now, people think insulin is good because diabetics take insulin, their blood sugar goes down. And God knows diabetics need their blood sugar to go down. I agree with that. What they don't understand is that insulin is actually the reason for the damage, not the glucose. Not the glucose. So this gets a little complicated, but I hope, work with me here. Okay, and audience, you work with me here too. Okay. If you look at type 2 diabetes, there are two different types of damage. There's the damage to the organs, like the retina and the kidneys and the nerves, retinopathy, nephropathy, neuropathy. And those are all small vessel diseases. And all of those are made better by lowering the blood glucose. So glucose is a driver of what we call microvascular disease, small blood vessel disease. No argument. And if you take people with diabetes and you get their hemoglobin A1C down by giving them insulin or by giving them oral hypoglycemics or by giving them virtually any medicine to get the blood glucose down, their retinopathy, their nephropathy, their neuropathy will improve. So glucose does damage to small vessels. Agreed. But there's also a second boat of type 2 diabetes problems, mostly heart disease, Alzheimer's disease, cancer. And it turns out those
all which have an increased risk if you have type 2 diabetes.
Exactly. And none of those are made better by lowering the blood glucose. In fact, they're actually made worse by lowering the blood glucose, because in order to lower the blood glucose, you had to give insulin. And it turns out the insulin is the driver of those pathologies, the heart disease, the Alzheimer's disease, the cancer. And the reason is because insulin does two things inside the cell. Okay? It binds to the insulin receptor, and there are two pathways in the cell. The first one is the metabolic pathway, the glucose-lowering pathway, and it's mediated by a transcription factor called AKT. Those, for lack of a better word, we can call good. But there's a second pathway, a second intracellular pathway, the cell proliferation pathway. Insulin drives mitogenesis. Insulin drives cell division and cell proliferation. It drives vascular smooth muscle proliferation. That's why you have increased risk for heart attacks. It drives vascular smooth muscle proliferation in the brain. That's one of the things that reduces the ability of the brain to get oxygen, which ultimately translates into dementia. And most importantly, it will induce proliferation of virtually any glandular tissue, such as, for instance, breast or prostate. And so there's your breast cancer, prostate cancer, pancreatic cancer. Insulin drives all of these. And so if you look at mortality, and there are 5 studies where they took type 2 diabetics and brought their blood glucose all the way down. If you look at those 5 studies and you look at retinopathy, nephropathy, neuropathy, they all got better. And if you look at heart disease, Alzheimer's disease, and cancer, they all got worse. And if you look at mortality, turned out those patients died at the same time as the patients whose blood glucoses were not reduced. In other words, short-term gain, blood glucose lowering, for long-term pain. That's insulin.
So what are some of the takeaways from that for somebody who's thinking about that context in their own sort of modern world of a lot of sugar floating around us?
So the goal is not just to keep your blood glucose low. That's true. We do want to keep our blood glucose low for a whole bunch of reasons, including because glucose can be turned into fructose, as per Rick Johnson. But we also have to keep our insulin low.
Right. Glucose is not the full story.
It's half the story.
It's half the story. And it's great that everybody's wearing a continuous glucose monitor around there.
And that's half the story.
And that's half the story. And I think that naturally people are waking up, and work that you're doing with companies like Levels, which I'm also an advisor to, they're also like, hey, listen, also get your insulin measured.
Right.
Because your fasting insulin gives you a much more robust part of the story. And there's a lot of factors that are at play. For example, in my own life, I saw that my average glucose from wearing a monitor was up slightly from what I could see my average on, but I started incorporating strength training into my routine more. And I was actually even eating a little bit more carbohydrates, not really like added sugar in my diet, but sweet potatoes and things like that, because I was going to the gym more frequently. Right. And my insulin had dropped during that time period.
Indeed.
So even though my average glucose was up a little bit, a few points, where maybe, my baseline when I would wake up in the morning would be, somewhere in the 80s or something like that, I was noticing it on a lot of days would be like 90s in the morning, a little higher, and my overall average was up. I don't want to say the exact number because I got to go back to the app and take a look at it. But my insulin during that same period, after about 2 to 3 months of working out more, adding lean muscle mass, which eats up your glucose, and doing more strength training, my fasting insulin came down. So that's why you're also saying that this is important to look at the 360 picture of everything.
Exactly right. So let me give you a different way
Please.
of looking at the same issue. Okay, and the audience will get this in a minute. Michael Phelps.
Olympic swimmer.
5 Olympics. How many medals? 23 golds, I think, altogether. Okay. Huge guy, right? I mean, he's got an arm span, like nobody else. Okay. Looks like a friggin' pterodactyl. All right. He consumed, on average, 12,000 calories a day when he was training. 12,000 calories a day. Now, they actually hooked him up to a energy expenditure monitor. He burned 6,000 calories a day in activity. Now, that's a 6,000 calorie surfeit. He should be gaining weight, shouldn't he? He should be gaining a lot of weight. He should be gaining 1.5 pounds every friggin' day, if it's about calories. He consumed 6,000 calories a day more than he burned. Where'd the extra weight go? Think about that. Turned out the reason is because his mitochondria were so efficient and he had so much muscle because he's Michael Phelps and he exercised like nobody else, that his resting energy expenditure was the other 6,000 calories a day. Your resting energy expenditure, Dhru, is probably around 2,000 calories a day. Now that you're training, maybe you'll be up to 2,200 calories a day. Okay, he burned 6,000 calories a day at rest. So he could eat 12,000, exercise 6,000, and still maintain his weight. So calories have nothing to do with this because it has to do with how many mitochondria you have and how well they're working.
Now, just a question on that is that, isn't it still that calories are part of the equation because the mitochondria are still burning the calories? He's just optimized them to a degree where they're a lot more optimized than somebody else's?
If your mitochondria are perfectly efficient, sure, but they're not because we have mitochondrial toxins everywhere. They're in the food. They're in the food packaging. They're in the air pollution. They're in the preservatives, the plasticizers, the flame retardants, the cosmetics, the wrapper, the cash register receipts at Target. Okay, they're everywhere. They are called obesogens, chemicals that contribute to obesity unrelated to calories. And there's a whole host of them. Air pollution is one. Particulate matter alters mitochondrial function. Radiation alters mitochondrial function. Actually, this is a concern for the Mars probe. When we send people up to Mars, what are we going to do? Because they're going to be exposed to much higher doses of radiation. It's going to cause their mitochondria to basically be destroyed. How are we going to feed people on the way to Mars? This is actually a big issue. And I've talked with the National Space Institute about this.
One thing that I've heard, not to take us off tangent, is that that's a big reason why they're thinking about, well, we just got to build cities underground because we have to minimize the radiation exposure, which I'm sure there's still going to be some excess because Mars doesn't have the same atmosphere.
Right. Absolutely. So there'll be, sitting ducks for every photon, coming across their bow. So this is a major issue. There are a lot of ways to kill your mitochondria. Mitochondria are relatively fragile creatures. And they are creatures, by the way. They are refurbished bacteria that we made a deal with, hundreds of millions of years ago, that we would house them in exchange for them producing energy for us, a symbiotic relationship. They are separate beings. They even have their own DNA, right? Mitochondrial DNA. So they only do a few things, so they can't live alone. But the fact is, we can't live without them. But they're very easily damaged, those mitochondria. And so if your mitochondria are damaged, then it is not about the calories. It's about how bad your mitochondria are.
So even for somebody like Michael Phelps, and I don't know too much about him, but we know y'all read that he was a huge consumer. And when you're young and you're very fit, you can get away with a lot. But he was a huge consumer of McDonald's and pizzas and just any way that he could get calories in.
Right.
So you're still saying big picture, and obviously you weren't studying him or working with him at the time. That is this sort of another reason why we are so pro exercise, that even eating a super ultra processed diet, his mitochondria is incredibly efficient?
So the question,
or just hadn't had a chance to catch up to him yet because he's generally young and fit.
Right. Take a look at every NFL player, what happens to them after they retire.
Yeah, tell us.
They get metabolic syndrome. They get Alzheimer's and they die. Now, some of them get CTE, chronic traumatic encephalopathy, and you hear about them because they blow their brains out. But lots of them get Alzheimer's disease. And the reason is because of the insulin resistance, because they're still eating like they were playing.
But they're not training anymore.
So their mitochondria have gone to crap. And they can't now process that energy load. And so now they're just sitting ducks, just like the rest of us. Now, this brings up a big question that I address in my book, Metabolical. There are 8, count them, 8 subcellular pathologies that are going on in the background in each of your cells all the time, every day, contributing to disease. Now, if you optimize those 8 subcellular pathologies, you'll be 110 playing tennis. If you don't optimize them, you'll be 40 years old on a gurney with 2 stumps, on dialysis waiting for your next stroke. And of course, everything in between. In the book, I call them the hateful or grateful 8. Now, these are subcellular pathologies that most of the audience will not have heard of. Although, if they listen to you, Dhru, they will have heard of them because everyone ultimately does talk about them. But their doctor does not talk about them. And the reason their doctor does not talk about them is because there's no medicine for any of them. And there's no ICD-11 code for any of them. So the doctor can't bill for them anyway. So here are the 8. Ready? 1, glycation. 2, oxidative stress. 3, mitochondrial dysfunction, which we've been talking about. 4, insulin resistance, which we've been talking about. 5, membrane instability. 6, inflammation. 7, methylation. 8, autophagy. These are the things that are going on in the background underneath the wire that are basically damaging cells and therefore damaging you, and the reason you die. Now, if you optimize them, you won't die fast. You'll die, a lot later and a lot healthier, right? Dying as young, how does it go? Dying late as young as possible. Dying young as late as possible. That's it. Dying young as late as possible.
Yeah.
Right. Like George W. Bush said. Dying young as late as possible. That's what we all want to do. And so if you optimize those 8 pathologies, the hateful 8, you will do just that. You will die very late. And that's the goal. Longevity, as Peter Attia, put in his book. I agree. The question is, what causes those 8? And the answer is bad food. Bad food causes all 8. And by the way, obesogens cause all 8. These chemicals in our environment cause all 8. What about exercise? Does exercise remediate any of those 8? Can you outrun a bad diet by mitigating these 8 phenomena? And the answer is exercise will fix 4 of them. So Is exercise good? Oh, absolutely. Exercise is great. And the fact that you're doing it is terrific. And the fact that Michael Phelps, burns 6,000 calories a day doing it, I'm all for it. And I exercise too, not as much as you. I'm also a little older. Okay. But the fact is, you can only mitigate 4 of them. Which 4 can you mitigate? You can mitigate mitochondrial dysfunction. That's good. You can mitigate insulin resistance. That's good. You can mitigate inflammation. That's good. And you can mitigate autophagy, and that's great. Okay, those are all good things to mitigate. So by all means, keep exercising, people. I'm for it. I've never said word one against exercise, but it's only the second best thing you can do for yourself. The first best thing is fix your diet, because then you can fix all 8 at once.
Can you give us a reminder of the 4 that exercise saying doesn't fix?
Sure. Glycation, oxidative stress. Actually, exercise makes oxidative stress worse. Membrane instability.
It's a temporary insult that increases oxidative stress.
Exactly.
But it has sort of like a hormetic type response in the body. It's not that you're saying that it's bad. It's just that it temporarily would increase oxidation.
It depends on whether or not you have the capacity to quench the reactive oxygen species. So if you eat well and you bring enough antioxidants on board, then you can mitigate the negative effects of oxidative stress generated by exercise. Good for you. But if you eat shit, and you can bleep that out. if you eat crap,
can we keep it?
Up to you. Your choice, Dhru. If you eat badly and you're not bringing enough antioxidants on board, and so those reactive oxygen species are not quenched at the level of the mitochondria, then where do they go? Those reactive oxygen species go to the endoplasmic reticulum, which is right next door to the mitochondria, and they will engage in the process known as the unfolded protein response, the UPR, or also known as endoplasmic reticulum stress, ER stress, same thing, unfolded protein response, ER stress. And what that means is that proteins that normally need to fold will now misfold. And when they misfold, they don't work. And when they don't work, guess what? You have cellular dysfunction. And ultimately, you can have cell death. That's what happens with insulin. That's what happens in the beta cell, is you end up with oxidative stress that affects the ability of the insulin molecule to fold. So you end up with misfolding of the insulin. It doesn't work. And so that's why the insulin levels go down. And that's type 2 diabetes, is reactive oxygen species in the beta cell keeping the insulin molecule from being able to be folded properly. The good news is, if you fix that, your insulin will come back. And that's why so many people are now able to reverse their type 2 diabetes by altering their diet.
So just going back to the diet and exercise example that you had there, just to make sure there's not any confusion, what you're saying is that even if somebody had some regular activity in their life, but was still consuming their calories primarily from ultra-processed foods, they would be in a situation where exercise is not making much of a difference for them at all.
Exactly right.
Right? It's not that you're saying that it's harming them. It's just not going to make much of a difference if the bulk of your calories, and again, if you're eating ultra-processed foods, chances are your calories are already up anyway, whether somebody prescribes or doesn't prescribe to the calories in, calories out model. We just know that people who are eating ultra-processed foods, their calories are way up. So then a moderate level of exercise, you may actually feel like it's not making a difference for you because it actually may not be making a difference to their body.
Exactly.
That's what I'm hearing from you.
That is exactly right.
So the best thing that somebody could do is, again, get off of ultra-processed foods, still keep their activity up and maybe even increase it depending.
Sure.
And moving towards a whole foods diet.
Absolutely. Okay. And the reason is because you need the other things in food aside from the macronutrients.
Right.
You need the micronutrients. You need the flavonols. You need the polyphenols. You need the biotin. You need all the other stuff that's necessary to let those reactions, those metabolic reactions in the body go efficiently. And you especially need them for your mitochondria.
Mm-hmm. So you mentioned glycation.
Glycation,
Yep.
oxidative stress.
Oxidative stress, which you talked about.
Okay. Membrane instability will not be fixed by exercise. The only thing that fixes membrane instability is omega-3s.
Mm-hmm.
Okay. So let me explain.
So your mitochondria
instability.
don't play a role in membrane strength?
No.
Okay.
Different phenomenon. In fact, your mitochondria are made of membranes, and that's a great way to end up with mitochondrial dysfunction, is to have membrane instability, because the fatty acids that make up the cristae of the mitochondria are all essential fatty acids that you have to ingest.
So give us a breakdown on membrane instability. What is the membrane?
So,
what makes it up? Why is it important?
Right. The membrane is the covering of the cell. Okay, the fatty covering of the cell. Here's the way to think about membrane instability. Take a balloon, blow it up. Try to put a knot in it. Try to poke a hole in it with your finger. Bounces right back. Okay. Try to take a pin and pop it. Now it'll pop. Okay. Take a new balloon, blow it up the same way. Put a knot in it. Put that balloon in the corner of your bedroom for 3 weeks. It will slowly but surely deflate. Now take the knot apart. Take the balloon, the spent balloon, and re-blow it up to the same level you did before. Put the knot back in. Now try to poke a hole with your finger. Now it'll pop. It wouldn't pop the first time, but it'll pop the second time. How come? Because the membrane changed. Because of the pressure altered the membrane constitution, okay, and rendered it more fragile. Well, this happens to all of our cells, and especially our neurons. So you have to replenish the membrane covering, the fats within the membrane, so that they can withstand the pressures of everyday existence. And what does that? Omega-3s. They contribute to neuronal structure. They contribute to membrane structure. In particular, the omega-3 called DHA, docosahexaenoic acid. Now, you need the other omega-3 also, EPA, which is eicosapentaenoic acid. You need that for neurotransmission. So you need both. Point is, where do you get those? Marine life. Now, why do you get them from marine life? Can't you get them from vegetables? No, you can't. There is an omega-3 in vegetables. It's called ALA, alpha-linolenic acid. And ALA is good. I'm not against ALA. ALA is a good thing. ALA is anti-inflammatory. ALA has been shown to help protect against heart disease. That's a good thing. And vegans like ALA. And I'm all for ALA. The question is, does ALA get turned into the other two? Does ALA get turned into EPA or DHA? And the answer is almost not at all.
Very poor conversion.
Very poor conversion. Extremely poor conversion. So basically, if you are on a vegan diet, you need your EPA and DHA too. You need to supplement those. And the question is, where are you getting them from? So if you're taking fish oil, okay, but a lot of vegans won't take fish oil because they're vegan. So this is an issue. This is something they need to know about.
Yeah. And what do you think about like algae oil and these things that are out there?
So algal oil is DHA. And, it's not the fish that make the omega-3s. The fish eat the omega-3s. The algae make the omega-3s. The fish eat the algae, we eat the fish. So we get our omega-3s third hand. Now, just so happens that algal oil is high in DHA, but relatively low in EPA. And you know how I know that? And you know how you know that? Because algal oil does not smell like fish. Algal oil basically smells like olive oil. But EPA eicosapentaenoic acid. That's where the fishy smell comes in.
Yeah.
And it's really hard to get algal oil into a recipe. It's really hard to get EPA into a recipe other than eating fish.
I mean, just a little personal testimonial I've shared on the podcast before, but I grew up vegetarian, was vegan for many years.
Okay.
Started to notice for the first time in university, I was feeling like I had the blues. I wasn't clinically depressed.
Really?
There was a lot of stuff that was going on in my life.
Okay.
And I started to be open to the idea that like maybe I didn't know everything about diet. I was a pretty staunch vegan at the time. I wasn't at protests and things, but anybody who would ask, I would say, here's why I think you should be vegan, because that's what I knew at the time.
Right.
And then later on, when I got introduced to the world of functional medicine, I ended up, one of the first tests that I did got me to personally, this is my own personal testimonial, I'm not advocating what people have to do. I did a $99 test, no affiliation with them, called the Omega Quant.
All right.
And it was a breakdown of my omega-3, 6, and 9. And I saw that my omega-3 was super low.
Right.
And it was the thing that got me to start including fish in my diet. And I immediately, within a matter of months, started to feel like my brain was turning on.
Fantastic.
That's just my own personal testimonial.
Okay.
And I know there's a lot of successful vegans that are out there, but I always like to share with my audience my own experiences.
I understand. And look, I have nothing specifically against veganism. And I want to make that very clear. Okay. Everyone's entitled to do what they want. But it's also true that everyone's entitled to do what they want. And that means that you don't tell me what I should do.
Right.
Either way.
Of course. Okay.
So I want to make that very clear. I'm very libertarian on this issue.
Mm-hmm.
My goal is to optimize everyone's health. And what I'm saying is that membrane instability is super important to try to mitigate.
We need to protect our membrane.
We do. And omega-3s have been, scientifically and empirically shown to mitigate that membrane damage, especially from insulin resistance, And it's also been shown to mitigate depression and several other psychiatric diseases.
So this begs the question that a lot of people ask about and there's debates upon, and, it kind of comes up in the world of nutrition on, a cyclical basis. And that's the idea that if omega-3s are protective, should people be worried about a large amount of omega-6 in the diet from seed and vegetable oils when it comes to these membranes?
Absolutely. So omega-6s are pro-inflammatory. Omega-6s are the precursor. Linoleic acid is the precursor to arachidonic acid. Arachidonic acid is the precursor to thromboxanes, leukotrienes, prostaglandins, all three pro-inflammatory. These are basically how your body clears infection.
And can I just ask you one question on that? This is where I think a little bit of the debate that comes up is that you have people like Dariush Mozaffarian from Tufts University,
who's a good friend,
who will come out there and, he got a lot of criticism with Tufts' involvement on the food compass approach and all the headlines that were out there, is Lucky Charms, healthier than steak and, things like that. But he would say, look at all the large observational trials that are out there that not only is omega-6 not inflammatory, but it seems to reduce inflammation when we look at these big epidemiological studies. And to that, what would you say to that? Especially because you know him and you know his background. Right. Why is it one person who completely feels one way about it and another person feels a completely other way about it?
I think it has to do with the ratio.
Okay.
We've heard that it's not so much the amount as it is the ratio. Mm-hmm. At least that's the story I've heard and read about. Now, have I researched it myself? No. But I've read all the papers. Mm-hmm. Our optimal omega-6 to omega-3 ratio is about 1-to-1. That's optimal. Mm-hmm. Our acceptable ratio is around 3-to-1 or 4-to-1. Our current median ratio in this country is 25-to-1. So we're getting a whole lot of omega-6s and not a whole lot of omega-3s. So the question you're asking is it just the omega-3 lack, or is it the omega-6 excess that makes the difference? And the answer is, who cares? We have a problem. And the problem is fixed by increasing the omega-3s in our diet. And if we do that, we'll be actually getting rid of the omega-6s.
I guess the only part of that feels a little confusing is, and again, for as little as you say that you've researched it, obviously you have more context of the ecosystem. Mm-hmm. And I'm not a researcher. I'm not a medical doctor. I always remind my audience, I'm just here to try to ask good questions. And I'm a student, just like everybody else out there.
Absolutely. No problem.
Is when they're referencing these large epidemiological trials,
right?
Generally people are going to be within this, the same ratio of omega-6 and 3 as the population, unless if they've sort of removed certain groups from that. Right. So if those people have the same on average ratio as omega-3 and omega-6, and they're showing that people who generally are having, again, I don't know what the conclusion is, but from what I heard from him on different podcasts is that, well, in fact, people who have more omega-6, there seems to be an anti-inflammatory component. So is that, I guess that's the part that I'm a little bit confused about. If it is about the ratio, but the studies that are epidemiological are showing people who have more omega-6s in their diet. So are you saying that those studies, it could be that they also have a good ratio of omega-3?
Yeah. So remember, it's the ratio, not the amount.
So we're not talking enough about the ratio of those individuals.
That's
it's not
right.
just that they have higher omega-6s. We may not be looking at the omega-3s.
That's right. You can't look at one out of context.
That'd be a good thing actually to look into. Now I'll follow up on that a little bit afterwards and see if that's the case, or if they have. I know Omega Quant themselves has assembled a lot of research that's out there, from what I've seen on their website, but that'd be a good thing to look at. Are they referencing that it's omega-6 in the context of 3?
Right.
And is that the reason why they still see a protective benefit? The way they make it sound, and other individuals who are sort of in that space too, like we've had Simon Hill on the podcast, and he said, look, I'm not a big fan of seed oils, but I just don't like all this demonizing of people saying seed oils are pro-inflammatory because the data doesn't support that.
Well, you need inflammation.
Uh-huh.
Okay. Inflammation's essential.
Well, I guess they're not talking about like daily sort of essential role of inflammation, right, but like the level that we talk about.
Right. Because
didn't you just refer to omega-6s as being inflammatory inside?
Oh, they're pro-inflammatory.
Pro-inflammatory.
Okay,
that sort of makes the audience feel like we don't want too much of them in the diet.
That's the assumption.
That's the assumption.
That's the assumption.
Okay.
Now, you need inflammation or you'd be eaten by the maggots. I mean, the fact of the matter is we have to have an appropriate inflammatory response to be able to fight off infection, viruses, COVID, etc. But the question is, what happens when you overdo it? Mm-hmm. Inflammation is one of the hateful eight, right? Inflammation is number 6.
Which you really mean chronic inflammation.
Chronic inflammation,
right.
Absolutely. Acute inflammation is essential for basically getting through the day.
Yeah.
But chronic inflammation is another story. And you don't need chronic inflammation. You don't want chronic inflammation. And the question is, where's that inflammation coming from? And the answer is it's coming from your gut. Your gut is a sewer, literally, figuratively and literally. It is a sewer. It's got all sorts of bad guys in there. And the goal is to keep the bad guys in the sewer and not let them into your bloodstream. And there's 3 barriers in your intestine that keep the bad guys in the sewer. Here they are. Number 1, physical barrier. The mucin layer. So there's a layer of mucus sitting on top of all your intestinal epithelial cells, providing a physical barrier between the junk and your bloodstream. Necessary. Well, that mucin layer can go away. That mucin layer can be eaten. What eats it? Well, the microbiome, if you don't feed it what it needs, well, it needs fiber. And so a fiberless diet deprives those bacteria of the food they need because they were eating the fiber. You've now starved them. And so what will they do? They will eat the mucin layer right off your intestinal epithelial cells, denuding them, and you lose one of your 3 barriers. What else eats your mucin layer? Emulsifiers. Emulsifiers are, by definition, detergents. They hold fat and water together. That's why you put Tide in your clothes washer to lift the stain out, because it will hold the fat in the stain and the water in the water together, and so you can lift the stain out. It's got one side that's hydrophobic and one side that's hydrophilic. Okay, and they form these little things called micelles in your intestine. Okay, that's how you basically absorb fats, is through these, by basically mixing fat and water together, an emulsion, an emulsifier.
And they're commonly used in foods, even natural products like carrageenan. That would be one?
These are things that are found in processed foods mostly. Yes, of course, there are some foods that have them in them, like seaweed has carrageenan in them.
Right, but we're talking about added emulsifiers for shelf stability.
Exactly, to hold fat and water together on the shelf. So polysorbate 80, carboxymethylcellulose, carrageenan. You know where carrageenan is most commonly found?
Almond milk, I think.
Ice cream.
Ice cream.
Ice cream. Okay, you got to hold fat and water together in ice cream, don't you? All right.
Yeah.
And do you know who introduced carrageenan to ice cream?
I don't.
Margaret Thatcher.
Oh, interesting. Tell me.
She was an ice cream chemist before she was an MP.
Wow.
Yeah, she really was the Iron Lady. Bottom line, emulsifiers have been shown to eat that mucin layer also. This is work from Elanov's group at Weizmann Institute in Rehovot.
And they're not like live bacteria. It's just that they degrade that layer.
Right.
Right?
Well, but now you've lost a barrier.
Now you've lost the barrier.
So, second barrier, the biochemical barrier. A protein that links the intestinal epithelial cells together called tight junctions. The most famous of which is zonulins, which are the things that go bad in celiac disease. That's what the gluten is targeting and causing those to drop out. And that's why you end up with leaky gut in celiac disease. So these tight junctions basically form a biochemical barrier between cells to prevent the transfer of bad guys, lipopolysaccharides, cytokines, whole bacteria, so that they don't end up in your bloodstream. And you can measure them in the bloodstream in celiac, and you can measure them in the bloodstream after ultra-processed food. Not okay. So you need your tight junctions to be working. Well, what causes those tight junctions not to work?
Is antibiotics one of them?
Well, antibiotics will change the microbiome, and the microbiome will then sometimes eat the mucin layer and will sometimes, generate its own toxins, which can cause problems.
Okay, got it.
But
yeah,
no,
so
there's something else that nitrates tight junctions. Fructose. Fructose nitrates tight junctions, and fructose increases the risk for leaky gut. And then finally, the third barrier, the immunologic barrier. So there's more immune cells in your intestine than anywhere in the body. And that makes sense because, after all, your intestine's a sewer. So there are all sorts of cells in the Peyer's patches inside your intestine, in your small intestine. And they are filled with cells called Th17 cells. And they make a cytokine called IL-17, interleukin 17. It's been shown that if you eat a whole foods diet, your IL-17 cells are great, and your Th17 cells are great, and your IL-17 is like it's supposed to be. If you eat a ketogenic diet, your Th17 cells are fine, and your IL-17 is fine, and your barrier is competent. And if you eat fat and sugar together, those Th17 cells are depleted, the IL-17 goes down, and fat in the fat sugar diet starts making its way across the brush border into your bloodstream and generates inflammation. So, bottom line, it's not just the emulsifiers, it's not just the fructose, it's the whole sort of 9 yards. It's what you're eating. But in every single case, ultra-processed food is the bad guy. And people need to understand that ultra-processed food ultimately is not food. Just because they say it's ultra-processed food and they use the word food doesn't actually make it food. So what is the definition of food, Dhru? Right out of the dictionary. What's the definition of food?
Yeah, we talked about it a little bit last time. Honestly, I forgot the exact definition, but yeah, right. Tell our audience.
Substrate that contributes either to growth or burning of an organism. That is the definition of food. It's a great definition. Substrate that contributes to either growth or burning of an organism. So if anything that you put in your mouth contributes to either one, growth or burning, food. Okay, let's look at ultra-processed food. Does ultra-processed food contribute to burning? In order to do so, you have to increase mitochondrial function.
Does it contribute to burning?
Yeah.
Which is connected to, does it lead to energy expenditure to process it?
Yep.
So in the case of like Michael Phelps, who's still eating a lot of ultra-processed foods, it would be contributing to burning, would it not?
Well, his exercise contributed to burning and his resting energy expenditure was higher. But like we talked about before, body temperature's gone down 1.5 degrees Fahrenheit over the entire United States over the last 150 years. Where'd that come from? Air conditioning? Really? This is mitochondrial dysfunction.
Our mitochondria not operating as efficiently, so they're not burning as much.
Exactly right. And specifically fructose, because of those inhibition of those three enzymes we talked about, AMP kinase, ACAD-L, and CPT1, carnitine palmitoyltransferase 1. So fructose is a primary component of ultra-processed food. 67% of the sugar in our diet is in ultra-processed foods. How about growth? Does ultra-processed food contribute to growth? It actually inhibits growth. So my colleague, Dr. Efrat Monsenigo Ornan at Hebrew University, Jerusalem, head of the Department of Nutrition there, actually showed that it inhibits cortical growth, it inhibits trabecular growth, it inhibits all sorts of bone growth. It hollows out the bones in your femur, and it also hijacks growth, like, for instance, cancer, like the Warburg effect. So if a substrate does not contribute to growth and does not contribute to burning, is it a food?
And, you know, we talked about this a little bit last time, and here's the part that I'm not saying that I'm confused on this, but that the part that I see, right? Sometimes I turn on the TV just to kind of see what kind of craziness is going on in the world, right? Yep. And there's a lot.
Yep.
And every so often I'll end up on a show, and there's some extreme ones on like TLC and other stuff of people who literally do not eat one vegetable, like individuals who are in their like 20s, 30s, 40s, 50s.
Yep.
And all they do is, you know, they make an entire show out of these folks. I wish I remember what the show is, but I'm sure you've seen it, right? All they eat is, you know, fast food hamburgers.
I stay off of TLC.
Okay. So, but just, I'm letting you know that this exists. Okay. It's, think of me as like, you know, a modern day archaeologist kind of looking and surveying the landscape. It gives me good podcast material.
Okay.
And honestly, I'm looking at it and okay, this person is quite severely overweight and obese. Right. And yet I'm still so surprised because these individuals are on TV saying like, I only eat soda, French fries, and I eat a burger, but I literally take the lettuce and the tomato off.
Right.
And yes, they're not healthy, but they're still alive and they're quite large. I'm amazed by how resilient the human body is, that I would have thought this person would have keeled over in their teens if they eat that way.
Well, indeed. But the point is that we are decreasing our lifespan. We have definitely decreased our health span, but we're decreasing our lifespan now. For the last 5 years in a row, mean age of death in the United States has continued to go down. And that is not true of the rest of the world. The rest of the world continues to go up. And if you look at, say, Japan as sort of the epitome, because they have the oldest people, their mean age of death in Japan is 86 years. The mean age of death in the United States is 77.5 years. So that is almost 8-year longevity tax that we pay because of our crappy food.
So it's really to say that ultra-processed foods, they may not be contributing to healthy burning and healthy growth.
Right.
That person is still alive, but just because they're alive, does
Doesn't
that
make
mean
them healthy.
that they're healthy?
Exactly right.
So it's not the ideal food, but in the case of these individuals, it's basically still a fuel source for the body. It just comes with all sorts of chronic disease, death, suffering, and countless other things along the way.
My only question is, Dhru, are those people listening to this podcast? Unlikely.
Unlikely. So this goes back to the larger idea where you're even questioning whether or not ultra-processed food is food in the first place.
Right.
From a philosophical standpoint, is this really contributing?
Well, from a reductionist standpoint.
Well, even from a reductionist standpoint, in a way, let's say we know that there's an association with people who are severely obese and cancer, and in a way, it's growing cancer, right?
Indeed. Absolutely.
Which may not be the thing that we want to grow, but it's still participating in the growth of something.
Well, it's
that thing is
hijacking.
decomposing us.
It's hijacking growth.
It's
Right.
hijacking growth.
Right.
That's a better way to look at it. Yeah.
Every cell in your body at one point in its life had to grow, and every cell in your body at one point in its life had to burn. Okay? Every cell grows, and then it switches off the growth and switches to burning. So there are two paradigms in every cell: growth and burning, growth and burning. The fetus has to grow. Think of it this way. Each of us starts out as one cell, a zygote. We end up an adult human being. 25 years later or so, right? Now, that one cell had to double to 2, and then the 2 cells had to double to 4, and on and on and on until you get to an adult. How many doublings does it take to get from a zygote to an adult?
I have no idea.
41.
Okay.
2 to the 41 cells will get you from a zygote to an adult. Now, of those 41 doublings, how many of them occur in utero and how many of them occur after birth?
I'm going to throw a number out there. I'll say 10 times doubling in utero?
36.
36. Okay, so the vast majority.
The overwhelming majority occur before you ever, breathe a whiff of oxygen. Okay. 36 and 5. Okay. 36 before birth, 5 after. And I'll prove it to you. So average baby, 7 pounds, double, 14 pounds, double again, 28 pounds, double again, 56 pounds, double again, 112 pounds, double again, 224 pounds. That's a big adult. But an adult.
Yeah.
Okay. 5 doublings, and you got from 7 pounds to 224 pounds. 36 doublings, 2 to the 36 before birth. Now, the placenta is the lowest oxygen tension place on the planet that still supports life? What is the partial pressure of oxygen in the placenta?
No clue.
31. What's the partial pressure of oxygen on the top of Mount Everest? 54. It's Mount Everest in utero. There ain't no oxygen in there, yet the cells are growing. 2 to the 36 doublings. How'd that happen? Because you don't need oxygen to grow, but you do need oxygen to burn. So what they're doing is they're poisoning their mitochondria. They're not burning. And so they've actually increased the growth paradigm by eating all that ultra-processed food.
The people that I was seeing on TV that you're talking about.
Exactly.
Yeah.
And so they've put themselves at risk for all of the growth paradigm diseases, coronary vascular disease, and especially cancer and Alzheimer's. So that's not a great thing to do.
Yeah, we don't want that.
We don't want that. Yes, you still make ATP. Yes, you still are alive. But for how long?
And I think that the person who's listening or watching today on YouTube, you know, one of their questions, of course, we know these extreme examples, right? Where people are significantly obese and overweight from a large percentage of their diet coming from ultra-processed foods. And even earlier, you were talking about, you know, when you combine sugar and fat together and some of the damage that does inside of the body.
Right.
Now, you and I have both eaten ice cream before, and you and I have both had sugar occasionally as part of our diet, dark chocolate, whatever it might be. Even maybe, you know, I don't drink sodas, but I will drink a natural quote unquote soda, which still would have plenty. Some added sugars inside of it, like an Olipop, you know? It's, you know, it's not something that I'm drinking every day, but it's something that I'll drink. And I think that people are asking the question, which is, what percentage, just to think of it this way, I know it's not just about calories, but what percentage of our diet can still contain, let's start first with ultra-processed foods, right? Again, ultra-processed, right? Which is different than processed, because processed is everything. Everything's processed.
Well, to some extent,
to some extent, right? But what is, if you were giving recommendation, or if you were the health czar in America and the president's coming to you and saying, all right, we need some recommendations for what percentage of calories in people's diets can come from ultra-processed foods, you would say what?
That's a tough question. Here's what I can say. Every percent increase in ultra-processed foods increases risk of cancer by 1.2% and diabetes by 1.5%. So I can't give you a threshold. I can just give you sort of the risk factor for doing it. I can't tell you specifically, oh yeah, stay below 10% ultra-processed foods and you'll be fine. Or stay below 30% ultra-processed foods and you won't get disease or anything like that. I can't do that because I don't know any study that's actually, you know, quantitated that in
and
that
we don't know
way.
the full impact of ultra-processed foods and their combination of their concentrated forms of delivering glyphosate to people, their concentrated forms of delivering PFAs to people, and these other obesogens that you were talking about.
That's right.
So you would be saying that, look, any significant amount of ultra-processed food in the diet, you're rolling the dice. You're gambling.
Exactly right. You're gambling. Now, some people, maybe the gamble will pay off. But in general, you're going to end up in trouble. And the question is, by that time, it'll be too late. So you have to make a conscious decision now, today, whether or not the risk is worth it and whether or not the expense is worth it. So the expense is two kinds of expense. The expense to your health and the expense to your wallet. And the way I always put it is, you know, you can either pay the farmer or the doctor. But ultimately, you're going to pay.
Yeah. And so let's now take it to sugar. And going back to our original sort of question where we were asking about what amount of sugar, because again, you and I both will have some sugar inside of our diet, even in the form of, we're not just talking about fruits, which you've talked about the benefits of having whole fruits in your diet,
Right.
but we might go out and we might have some ice cream occasionally.
Yeah,
We
sure.
might have something that's there. You know,
It's not what you do on one day. It's what you do every day.
So even every day, because I think a lot of people get confused still, because generally if you go to Times Square and you interview most people and you say, are you eating healthy? Pretty much everybody's going to say yes, because they all, I only have 5 soft drinks a day. My cousin has a whole liter. Right. So I'm doing better than them.
As they walk into Nathan's. Yeah.
As they walk into Nathan's. Or, are you healthy? Yeah, I only smoke 1 cigarette a day. Right? Because that's their definition of healthy compared to the people that they spend time with. So I actually think there's a lot of people that are listening that are like actually genuinely confused when they're looking at nutritional labels and the food that they're eating. Is there a threshold, since our government isn't putting any sort of values of what is the total amount of sugar? And this has become a big debate because right now, going back to, you were mentioning the Obama White House and Sam Katz, right?
Sam Katz, yeah.
He's now an advisor on a new drink that's been launched by Michelle Obama.
I'm aware. Plezzy.
I got it. And there's a lot of debate on Twitter that people are having because it has 10% of its sugar is added sugar, I believe.
Right.
And I'll fact check that and put it inside of the show notes.
Right.
And there's people that are attacking, Michelle Obama, former First Lady, as well as Sam, as well as Emily Oyster, who's part of it, an advisor. And they're saying there should be no added sugar that's being recommended to people.
Right.
And they're coming from a standpoint, and you've written about this. You actually put a whole study about this out there that we actually, if we're going to, and correct me if I'm wrong in the sort of how I'm portraying this, we have to make processed foods healthier.
Right.
If we are going to be realistic in getting people to change.
Right.
So that's a lot of stuff that I brought up. But let's first start off with the sugar thing.
Dhru,
and then I want to get your thoughts on Plezzy.
Dhru, you're so absolutely correct. At every level. Okay. So let me first explain to the audience.
Yes.
I am not a purist.
Mm-hmm.
I am a practicalist. I'm a pragmatist. We can't get rid of processed food. As much as I hate it, we just can't. And the reason we can't is because we have to feed 10 billion people by the year 2050. And how the hell are we going to do that? There's not enough land and ocean.
And would you also say that you feel that same way about sugar? Added sugar in the diet?
So let me explain.
Please, yes, sorry.
What I know and what we've done. And this will be the entree for that. Okay. Sugar is a chronic, dose-dependent mitochondrial toxin.
Mm-hmm.
In the same way alcohol is. And for the same reasons, because after all, where do you get alcohol from? Fermentation of sugar. It's called wine. We do it Napa Sonoma every day. The big difference between alcohol and sugar is that for alcohol, the yeast does the first step called glycolysis. By the way, same as anaerobic metabolism. Same as cancer. And for sugar, we do our own first step. But after that, what gets presented to the mitochondria are exactly the same, whether it's alcohol or sugar. So it shouldn't surprise us that children today get the 2 diseases of alcohol, type 2 diabetes and fatty liver disease, without alcohol. Because sugar is the alcohol of the child. And I have written that many times.
Yeah, you've said in previous interviews that when you were in med school, if you saw fatty liver disease, you knew that person was alcoholic.
Absolutely.
Now today, you're seeing all sorts of people, especially kids, who have fatty liver.
5-year-olds.
And they've never touched alcohol.
Exactly. 5-year-olds with fatty liver disease. And fatty liver disease is now the leading cause of liver transplant. So, yes. Kids are now basically getting the diseases of alcohol because sugar is metabolized like alcohol. Does that mean they should go cold turkey and never touch the stuff? And the answer is, well, we have a threshold for alcohol. How many drinks a day can you consume before your health goes down the tubes?
I mean, this is an area that's hotly debated.
Yes. So how many?
Well, if you listen to Andrew Huberman's last episode that he did, not last episode, but it was, I think, the second most listened to podcast last year on alcohol, is that, he would say that there's no level of alcohol that doesn't do, some form of damage on the body.
It's true.
I guess the government's recommendation, I've seen things for women that it's like 2 drinks a day?
One.
1
for women, 2 for men.
Okay.
That's sort of the upper limit.
Yeah.
Okay. 1 drink will get you about 25 grams of alcohol. Well,
is that a beer or is that?
No, that's
hard liquor or wine?
That's more like wine.
Okay. Got it.
Glass of wine. Beer's a little lower. Beer's about 105 calories, 3.5% alcohol. Wine's about 140 calories, more like 8 to 14% alcohol, depending on whether it's white or, a bold red. Okay. So, but the point is, you won't do a lot of damage. There's no amount of alcohol that's good for you. That's what we've learned. We used to think, 1 drink a day actually is good for your liver.
Right. But then if you haven't started,
to not be true.
Don't start is what they would say, which was always so confusing.
That's true. That's true. But the question is, when does the cumulative damage start?
Right.
And Huberman's right that there's no amount that's good for you. That's true.
Right.
But it's when does the cumulative damage start? And the answer is around 1 drink.
1 drink. More than 1 drink a day.
More than 1 drink, you're going to have problems.
Yeah.
Okay? All right. Our livers have an innate capacity to metabolize alcohol. Our livers have an innate capacity to metabolize fructose at about the same level for the same reason. So how much fructose can you consume? The answer is about 25 grams of sugar, so half of that being fructose. So about 12 grams of fructose, 25 grams of sugar.
And how much is in...
that's about 6 teaspoons of added sugar per day. For the whole day.
6 teaspoons of added sugar for a whole day.
For a whole day.
And if you look at like a can of traditional sugar sweetened soda.
Okay. That is 10 teaspoons.
So already you have 10 teaspoons of sugar in just one can of soda.
So half a can of soda, and that's it for the day.
And you're already over.
And then you're already over.
You have 10 instead of 6.
Right. Because we have a limited capacity to metabolize it. People don't understand that. People think, well, it's just calories. Nope. It's sugar. Okay? There are acute poisons that will kill you in parts per billion, keel over and die, like cyanide or ricin or sarin or VX gas. All right? There are intermediate toxins where you need a little bit more and perhaps a little longer exposure, like, for instance, carbon tetrachloride or benzene or tobacco smoke. And then there are relatively weak toxins, like alcohol and sugar, where it's probably not 1 day's worth of exposure that's going to kill you. It's going to require 10 years to 30 years of exposure. And it's not 1 cigarette or 1 immediate, exposure. It's going to be multiple chronic exposures, but ultimately it's going to kill you. And the question is, when you get to that point, will you say to yourself, well, I had a good life and I enjoyed my sugar? Or are you going to say, what the hell did I do? You can only make that decision if you have the knowledge. And we are being kept from that knowledge, very specifically by the food industry, because they don't want you to know.
And it's not like you're saying that you just wake up one day and you die 10 years early, because there's a lot of people that say, you know what? If it's a longer life or I get to, live to eat, and sure, I'm going to have a little bit more sugar and alcohol and other things, but they forget the fact that chronic disease is painful as fuck.
It sure is.
Diabetes is painful.
Absolutely.
Alzheimer's is painful.
Absolutely.
You don't just wake up one day and die peacefully a little earlier. You suffer for years.
15.
If
15.
That sounds like a good case scenario
Average.
from
Average.
the people that I've seen.
That's how much reduction in health span we see.
Not to mention your
with
cognitive
metabolic
performance going down.
That's part of it. Yeah.
Your energy going down. Like I have sugar in my life. Like I will have an ice cream here and there or a component, but I treat it kind of like I did growing up when my family moved here, is that it wasn't in the home. It was an occasional thing that we had to go outside of the home for.
Right.
And it wasn't a regular part of my diet, minus like dark chocolate and fruits and other things, which we're not really talking about.
Look, when sugar was a condiment, we did not have this problem. But sugar became a diet staple. And now we do have this problem. So here's another way to look at it.
Please.
I am for dessert.
Can I clip this for social media?
Absolutely. I am for dessert. For dessert.
Yeah.
I am not for dessert for breakfast, lunch, snacks, and dinner.
Yeah.
Breakfast cereal is dessert. Yogurt is dessert. Chinese chicken salad is dessert. So you have to rethink the food that enters your mouth and reclassify it. Dessert? Not dessert. What determines it? Enough said.
Even when the sort of traditional folks that believe in energy balance say, look, sugar is not an issue as long as we control for calories, right?
And that is absolute hogwash.
I'd love you to expand on that because I genuinely am somebody that is trying to make sense of it all, right? Because you're saying that you're for dessert. And obviously the vast majority of Americans, and now increasingly the world, we're exporting the standard American diet.
Right.
People are not eating within the traditional sense of calories. They're overeating, and they're overeating on ultra-processed food, which also comes along with a lot of sugar. But if somebody came in and said, hey, if you're exercising and you are generally watching the total level of calories you have, then don't pay attention too much to sugar independently. Why is that not correct?
2 reasons. First reason, alcohol. Okay, so alcohol is 7 calories per gram. So in order for alcohol to be an obesity and metabolic syndrome producing substance based on calories, you would have to consume basically about 50 grams. About 350 calories of alcohol to make it that true. So 50 grams of alcohol. How much alcohol is that? That's a lot of alcohol. All right. We just talked about,
So you're even saying that even though alcohol is not that high in terms of total calories,
right,
it still has a super detrimental impact on the body.
Alcohol is not dangerous because it's calories. Mm-hmm. Alcohol is dangerous because it's alcohol.
Right.
Sugar is not dangerous because it's calories. Sugar is dangerous because it's sugar. For the same reasons. That's the first reason. Second reason, we talked about it earlier, leptin resistance. The inability to see your leptin. The higher your sugar consumption, the more your insulin resistance. The more your insulin resistance, the less well your brain can see its leptin. The less well your brain can see its leptin, the more your brain thinks it's starving. And the more you'll eat those calories. So you can get your calories down, not by starving yourself, not by dieting and caloric restriction. You can get your calories down by getting rid of the insulin resistance, which means getting rid of the sugar, because that's what caused the insulin resistance, because it's the fat in your liver that led to the insulin resistance, because your pancreas makes insulin to make the liver do its job. And when you've got the fat in your liver that the sugar caused, now your now your liver doesn't do its job. Now your pancreas has to make extra insulin. Now you've got insulin resistance. Now you've got high insulin levels at the brain. Now your leptin doesn't work. So all of those extra calories you're eating is because your brain doesn't see the leptin because of the sugar you ate. Fix the sugar, you'll fix the calories too.
And this,
Now, but it doesn't work the other way around. So it's not about the calories. And I'll be happy to debate anybody who says it does.
So as a byproduct of this, you would also say that somebody could have their calories within range. They could even be at their sort of a match between their general day-to-day energy expenditure and their calories. But if we look at their labs and their fasting insulin, that could be really high.
Could be.
Even if their calories are within range.
So there is a phenomenon, which I think we talked about at the last time I was on the podcast. It's called TOFI, T-O-F-I. Thin on the outside, fat on the inside, real medical term. 1,500 Medline citations, coined by Dr. Jimmy Bell, neuroimager at University College London. You can be thin sick, and you can be fat healthy. 20% of obese people are fat healthy. Now, 80% are fat sick, I agree. Okay, no argument.
Did you say
obesity
overweight?
is a risk factor?
Did you say overweight or obese?
Obese.
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 So that is significantly, that's like, I don't know in terms of BMI, but you're talking
BMI
about
over 30.
BMI over 30. Okay.
So 20% of obese people, though, are healthy.
From like your typical metabolic labs.
From the metabolic labs and for the diseases of metabolic syndrome, type 2 diabetes, hypertension, dyslipidemia, cardiovascular disease, cancer, dementia, fatty liver disease, polycystic ovarian disease, the diseases that are killing Americans. 75% of healthcare dollars are due to metabolic syndrome diseases that sugar drives.
So 20% of those people that are obese, they still could be healthy.
Absolutely. Conversely, 60% of the normal weight population have the exact same diseases as do the obese. Normal weight people get type 2 diabetes, hypertension, dyslipidemia, cardiovascular disease, et cetera, et cetera, et cetera. Okay. Now they get it at a lower BMI. So it can't be the obesity because they're normal weight. Their BMI is below 30. Okay. They're thin sick as opposed to fat healthy. So just because you're thin doesn't mean you're healthy, and just because you're fat doesn't mean you're sick. So there's this thing called TOFI. So my question to everyone listening to this podcast right now, look at yourself in the mirror and ask yourself the question, am I a TOFI?
And generally, a lot of people wouldn't know this, but what body fat percentage would that be? Right?
Well, it could be very little body fat percentage. Depends on where the body fat is.
So you're talking about abdominal body fat.
No, I'm talking about liver body fat.
Liver fat. Which isn't that correlated with the abdominal body fat too?
Usually,
like
but
you
not
see a lot
always.
of Indians and South Asians that are TOFI.
Usually, but not always.
Not always.
That's right. Usually, but not always. So here there are 3 fat depots in the body. 3. Okay. And they contribute differentially to disease. This is very important. Fat depot number 1, subcutaneous or big butt fat. As in, does this bathing suit make me look fat? Never answer that question. Total loser. Okay. Guaranteed. Okay. Now, here's the question. How many pounds of subcutaneous fat do you have to gain before you get sick?
Ooh. I'd love to know.
About 22 on average.
Okay.
10 kilos,
before
22
type
pounds.
2 diabetes and other things comes in.
Exactly.
Okay.
22. Now, why so much? The answer is because subcutaneous fat does not drain into the liver. Subcutaneous fat drains into the heart. So when subcutaneous fat accumulates, the border of the fat vacuole in the fat cell starts to break down. The grease gets spilled. The macrophages come in to clean up the grease. They release the cytokines. The cytokines then circulate in the peripheral bloodstream, which is 6 liters. And so the concentration doesn't go up very high. And so the liver doesn't see a very high concentration of these cytokines. And it's the concentration of cytokines that the liver sees that determines whether or not the liver gets sick. So about 22 pounds. All right, fat depot number 2, visceral fat, belly fat.
And the fat between organ systems.
Yes.
Yeah.
The visceral fat, it's called. How many pounds or kilos of visceral fat do you have to gain before you get sick?
I would guess it's probably less than 22.
5.
5.
Maybe 6. Okay? 22 for sub-Q fat because it drained into the general circulation. 5 or 6 for the visceral fat because it drains into the portal vein. The portal vein goes straight to the liver. So if your visceral fat accumulates and you start breaking down that fat vacuole and the grease starts spilling and the macrophages start coming in, okay, those cytokines are going to be at much higher concentration because they only have to populate the portal system, the portal vein, from the gut to the liver. There are 2 portal systems in your body. What's a portal system?
What's a portal system, and also what is draining? Like, what is actually draining?
Exactly. So that's right. What does it drain? So normally, the way blood goes in your body, it goes heart, aorta, artery, organ, vein, vena cava, heart. Okay. That's called a systemic circulation. A portal circulation goes like this: heart, aorta, artery 1, organ 1, artery 2, organ 2, vena cava, heart. So the blood has to go through 2 organs to come back to the heart. And there's information being carried from organ 1 to organ 2, which tells organ 2 what to do. So there are 2 portal systems in the body. One is the hypothalamus to pituitary. We know why that is, because that runs all the different hormonal systems of the body. And the other one's pancreas to liver, because the liver is the primary target of insulin action. And so when the liver gets fat, the pancreas has to make more insulin to make the liver do its job. And because the liver gets fat and because it's at the end of that portal system, the liver doesn't have to get very sick for the pancreas to start making extra insulin and causing problems. Now, the question is, where did the visceral fat come from? Did it come from the diet? No. People think that belly fat is from the diet. No. This is the big, mistake.
Yeah,
big
where
miss.
does it come from?
Stress. And the reason we know that is because you can take people who are chronically depressed, who are suicidal, who basically have to be admitted to the hospital to keep themselves from killing themselves. And you put them in a scanner, and they're not eating. And so they're losing weight. Hallmark of depression, losing weight. And their subcutaneous fat is going down, and their visceral fat is going up. They're losing weight, and their visceral fat is going up. Because cortisol, the stress hormone, is the driver of that visceral fat.
So would you say that for most people that are dealing with belly fat, stubborn belly fat, that stress is the primary driver?
Absolutely.
I guess where that's a little bit, where I'm trying to contextualize that is that those people also probably, the vast majority, are also still consuming extra calories.
Of course, because that's one of the treatments for stress, is overeating.
So you could say that you could potentially create a control experiment where you had people losing weight, you stress them out to such a degree that the cortisol is increasing in their body and their belly fat goes up.
So we did the opposite at UCSF. We did a study where we took patients with exactly that situation and taught them mindfulness.
So yeah, can you explain what that study was?
So it's
like
called
what was the condition?
It was called the SHINE study.
Were you controlling for what they eat or anything else like that?
We took postmenopausal women and we basically taught them how to meditate.
So you weren't controlling their food or anything like that.
We didn't touch their food. We only taught them to meditate. But we studied them before and 6 months and 18 months later.
And when you say studied, what were you looking at?
We were looking at their fat depots.
And cortisol as well?
Cortisol and also insulin and insulin resistance. Exactly. And what we found was that weight didn't change that much. But in the mindfulness group, their belly fat went way down and their insulin levels went way down.
Could that also be, just asking, is that also a byproduct of you've lowered your stress, you're doing less sort of stress eating and coping, and so naturally you're sort of adjusting and not reaching out for sugar and processed foods?
Exactly.
So you're not saying that calories wasn't a part of the equation.
Well, but they didn't lose weight.
They didn't lose weight.
They didn't lose weight.
But there was an adjustment in where that weight was distributed?
Exactly. And that correlated with improvement in their metabolic health, unrelated to weight. Another reason why this is not about calories.
You could have a situation where somebody's body composition is adjusting, right? So they don't lose weight, right? Like I get caliper tested every couple of weeks as part of my working with this trainer, and it's part of my goal, having turned 40 and making sure my lean muscle mass stays strong, but that I still do it without, but keeping my fasting insulin low, keeping my glucose balanced. So my body composition is adjusted sometimes where my fat percentage is going down. You can see a little bit more of my abs, but my lean mass is going up.
Right. And you measure that on the scale. Exactly right. The more muscle, the better off you are.
But there could be a week where my weight kind of stays the same, but my body composition is improving.
Indeed. And that's what we showed in this mindfulness study. So it's called the SHINE study. It was run by Rick Hecht and Alyssa Eppel, my colleague.
We've had her on the podcast before. She's great.
Absolutely. She was the co-PI on this. And we showed that mindfulness did not change weight. It changed health because it got rid of the cortisol, because it got rid of the insulin resistance, because it got rid of the visceral fat.
Would one way to know that even the next degree, could you potentially control calories and really drive it home potentially?
Sure.
Is that a possibility?
Sure.
I'm just sort of asking, I'm stress testing the idea because we have so many people in our audience who hear different sides of the story from different people. And I'm just trying to, because I have this time with you, I'm trying to ask the tough questions that enlighten us all.
Right. What that would do is that would help reduce subcutaneous fat, which of course is the fat that everyone sees.
Right.
But it's not the fat you can see that makes you sick. It's the fat you can't see that makes you sick. That's the nugget of truth that people don't want to own up to.
So the fat deposits. One was the subcutaneous fat. One was the visceral fat.
And number three. Liver fat. So how many pounds or kilos of liver fat do you have to accumulate before you get sick?
It's got to be a super tiny amount. It's got to be probably less than like,
half a kilo, 1 pound.
Okay, got it.
Now, can you measure 1 pound on the scale?
You can.
No, you can't.
You can't.
No, you can't.
Because there's so much
poop.
Yeah. I mean, there's so much weight fluctuation.
It's in the realm of error.
Yeah.
Okay.
Depending on your bowel movement that day, and a bunch of other things.
Yeah. No, you can't measure 1 pound.
So people don't know that they're getting fat in their liver.
Exactly. But the fat in your liver is the primary driver of that chronic metabolic disease. And today, 45% of Americans have fatty liver disease. Considering that no one had ever heard of non-alcoholic fatty liver disease before 1980, and now 45% of Americans have it, that is the biggest epidemic in the history of the world, including COVID. And
you're saying that is driving chronic disease?
Exactly.
But also our obesity epidemic?
Well, if you become insulin resistant and your pancreas has to make more insulin and your insulin levels rise, and then that insulin works on your adipocyte, yes,
because having a fatty liver is part of the process of somebody ultimately becoming insulin resistant.
Exactly right.
It's mind-blowing when you start to understand it.
So 22 pounds of sub-Q fat equals 5 pounds of visceral fat equals 1 pound of liver fat. You tell me which one's worst. What is the worst?
I mean, it sounds like essentially what we're doing is we are creating foie gras with our entire population. We're force feeding sugar.
And what do you give to the goose to make the foie gras?
Corn, I believe.
Well,
right?
refined carbohydrate, but you know what makes it go faster?
What? Sugar. So like, what are they serving to the goose to create this fatty liver that is served as a delicacy, which we call foie gras?
Oh, well,
I don't eat it.
They don't serve it. They stuff it.
Yeah, they literally shove it down its throat.
They shove it down
which
its
is why
gullet.
it's considered a cruel practice.
Exactly.
But what is the mixture? Do you know what they're giving them?
It's a corn sugar mixture.
Corn sugar. So
corn and sugar.
Corn and sugar.
Yeah.
Would it have a large percentage of fructose?
Yeah.
Yeah.
Yeah. That makes it the fastest.
And so essentially most people are doing this voluntarily because ultra-processed foods are so addictive and their palate and their brain has been hijacked.
Right. And it's soft drinks that are the main lining of that sugar to
Soft
create that
component.
fatty liver. That's right. So we have to fix that first. And when you fix the fatty liver, you'll fix the insulin resistance. When you fix the insulin resistance, you'll fix the insulin. When you fix the insulin, you'll fix the leptin. When you fix the leptin, you'll fix the weight.
Which is why your classic tagline, if you could repeat it for us, starts off with protecting the liver.
So let's talk about how we can all fix this. In my book, Metabolical, I basically say that in order to turn metabolic disease around, you have to adhere to 2 precepts. Protect the liver, feed the gut. 6 words. Protect the liver, feed the gut. 2 clauses, 6 words. Now, the reason I did that, the reason I said that was because Michael Pollan, in his book, Food Rules, said 7 words. He said, eat food, not too much, mostly plants.
Right.
I had to come in under that.
Yeah. But would you still agree with that advice of Michael Pollan?
No.
You don't think that gets the full equation?
Michael's a friend. I've had him to dinner at my house and his wife Judith, and they're wonderful and delightful. I actually think that those 3 clauses are all incorrect. Eat food. Well, we just learned that processed food is not food. Mm-hmm. Not too much.
Well, he doesn't consider like ultra processed foods.
I understood.
But he does say if you can make it inside the home, he's okay with French fries as long as you make it inside the home.
Yeah.
But he knows that that's very tough to do.
Right.
But you guys still disagree. He would still consider French fries food, and you don't consider that.
If you burn the olive oil, maybe not, when you're making the French fries. Not too much. Well, you know what? If you fix the leptin resistance, you won't eat too much of your own volition. You don't have to worry about it.
But you still do agree generally that we don't want people to eat too much.
Of course.
But you guys have a different opinion on sort of the mechanism of getting there.
Right.
Okay.
And finally, mostly plants. Well, don't forget Coke, Oreos, and Doritos are all vegan. So I had to come in at fewer words than 7. So I said, protect the liver, feed the gut. I lied. There are 3 more words. Support the brain.
Right. I was going to say it's incomplete. There's a little bit more to it.
And I thought about it and I thought about it. Do I want to put this in the book? Do I want to put this in the book? If I do this, it's going to increase the number of chapters by 4. And it's already 416 pages. Do I really need this? And I decided, you know what? Save it for the next book. But there's actually 9 words. Protect the liver, feed the gut, support the brain. We call this now, this rubric of 3 principles, the metabolic matrix. These 3 clauses: protect the liver, feed the gut, support the brain. Now, we started talking about how are we going to feed everybody. We started talking about the fact that ultra-processed food is not going away. And to be honest with you, I don't even think we want it to go away because we have to feed 10 billion people by 2050. And we're not going to be able to. We can't afford the food waste, and we can't afford the inefficient land use that is inherent in real food. As much as I want processed food to disappear, I know it won't, and I know it can't. And of course, the food industry will never let it because this is way too profitable for them. So this means that we have to come to some peaceful coexistence, like we did with tobacco, like we did with alcohol. We have to find a peaceful coexistence. This is why I said I'm not a purist, I'm a practicalist. We have to somehow find a way to make processed food healthy. And we've done it. And we've done it. So let me tell you about my most recent project.
Which was also a paper?
Which we put out in Frontiers in Nutrition, came out March 30th. And the title of the paper is The Metabolic Matrix, Re-Engineering Ultra-Processed Foods to Protect the Liver, Feed the Gut, and Support the Brain. The first author is Tim Harlan, who is the head of culinary medicine at George Washington University. Rachel Gao is the second author. She is a fatty acid expert and ran the NIH's omega-3 ADD trial. Third author is Andreas Kornstadt, who is a data scientist, computer scientist from Stanford, who lives in Hamburg. Fourth is Wolfram Alderson, who happens to be my social media director and also happens to be a food activist and advocate for his entire career, and then me. In 2020, I get an email from the chief business officer of a company I'd never heard of. Kuwaiti Danish dairy company. They're in Kuwait. They're like the Nestle of the Middle East. They make lots of crap. They make frozen yogurts. They make ice cream and flavored milks and confectionery and tomato sauce and biscuits and, like everything that's bad. And of course, Kuwait has an 18% diabetes rate and an 80% obesity rate. Now, the founder and CEO of this company is a gentleman by the name of Sir Mohammed Jafar. Now, Sir and Jafar don't usually go together. He's a Kuwaiti national who was born in the UK, and he's founded this company, and KDD fed the Kuwaiti population through the first Gulf War. And Queen Elizabeth knighted him. Sir Mohammed Jafar. Wonderful guy. Terrific guy. Think the world of him. But Sir Mohammed had a problem. He weighed 400 pounds, and at age 48, he had developed type 2 diabetes.
Wow.
And he went to his UK physicians, and they put him on insulin and oral hypoglycemics, and he got worse. And he felt like shit. And so he started researching himself on the internet. And he found Jason Fung, nephrologist in Toronto, who's a big proponent of intermittent fasting, and me. And he started doing what we said. And lo and behold, within 9 months, he had lost 100 pounds. His type 2 diabetes went away. His back pain resolved. And he thinks we hung the moon. Okay.
Incredible.
And then he has his aha moment, his moment of epiphany. And he says, holy shit. If I did this to myself, eating my own crap, what am I doing to the rest of the Middle East? So he talks it over with his sister, who's the chief financial officer. And they agree. They're privately held. They don't have, Wall Street quarterly reports. They don't have stockholders to placate. They're going to turn this company around. And they're going to make processed food healthy. They're going to be part of the solution instead of part of the problem. And so the chief business officer of KDD emails me, would I have an audience with Sir Mohammed? Sure. So we have a lovely conversation over Zoom during the pandemic. And he stakes us to developing a scientific advisory team, which I've just mentioned, and to basically evaluate their entire 180-item portfolio to determine what needs to stay, what needs to go, how to make what stays healthy, and how to re-engineer it and how to market it. Wow. By the way, I took no money for this because it's a food company, conflict of interest. Did this gratis.
Even that means, you funding the team, like everybody's time?
So everyone cut their own contract.
Everybody had an individual relationship. You're just saying your relationship
my
was
relationship
you didn't take on any
was
money.
No money in my pocket.
Yeah.
For this effort. Okay. Conflict of interest. I'm very, very clear. I do not take money from food companies. Mm-hmm. Okay. Anyway, we developed a procedure. We developed a set of principles. We developed a tier system to determine how to get from tier 3, which means basically poison, all the way up to tier 1, which would basically be the healthiest thing on the planet. And what steps had to be achieved and what criteria had to be met. We sent all of their ingredients that they use for biochemical analysis by a company called Eurofins, which is in Des Moines, Iowa, so that we knew exactly what was in the food, so we knew what we were dealing with in the first place. We rethought all of their recipes. We rethought all of their components. For instance, there are no cows in Kuwait because it's too hot. They get all of their milk from milk powders from New Zealand. Well, what were the cows in New Zealand consuming? What was in the milk powders? We had to test it. Was there any omega-3s in the milk powders? We had to test it to find out exactly what we were dealing with to start with and whether or not KDD had to change vendors in order to be able to do this. We had to think about how to get certain ingredients into the food, like omega-3s. And how would we do that? We had to talk about sugar a lot. What are we going to do? And we said, if we take the sugar out, you can't make ice cream, you can't make frozen yogurt, you can't make flavored milks. You could put diet sweeteners in, but that's not so good. How are we going to do this? What diet sweetener would we use? So all of these things went into the hopper in terms of figuring it out. We also had to be able to sell it because we're not trying to put KDD out of business. We're trying to actually help them grow their business, not kill it. So we had to talk about the role of fructose on the reward center. We figured out that we had to keep 1 teaspoon of sugar per serving in order to get that nucleus accumbens activation, to make the food worth eating. Have you ever tasted a no sugar chocolate bar?
Oh, yeah. Like 100% cacao?
No. Like with, like sweeteners.
Meaning it has no sugar.
But it's sweet.
It's sweetened with like stevia.
Yeah.
Yeah, I've tried some of those. Yep.
What do you think of them?
You don't get that full sugar effect.
Right.
Like a Lily's brand.
Do you ever want to go back for another one?
My palate is different,
So is mine.
So I will sometimes go back for them, right? There's a brand called Lily's. I don't try to do a lot of sugar alcohols. Yep. But I'll sometimes
now we know erythritol is associated with cardiovascular disease.
That's a little controversial because the study wasn't well done, and we had a lot of people kind of dissect it.
It's a meta-analysis, and it's garbage in, garbage out. I got it.
Yeah.
I got it.
But there are some concerns that people have. In particular, my body tells me immediately, and I have a very sensitive gut. So if I have too much erythritol, I feel it in my gut right away.
Many people do.
So, but going back to your point that you were making, you were asking me, like, have I ever had chocolate that is not sweetened with sugar? You said, do you ever want to go back? And I said, well, my palate's a little bit different. I do sometimes, but I don't want to reach for it the same way that I reach for real sugar.
Right, exactly. So we needed to basically spike the whatever the product was with enough sugar to make it valuable from a taste standpoint, but not enough to cause damage.
And that for you found out was a teaspoon.
One teaspoon. 4
per
grams of sugar, 2 grams of fructose.
Mm-hmm.
Recognizing that the ultimate lid, the upper limit, is 12 grams.
And how did that compare for what previously they had per serving?
It's like, a 77% reduction.
Mm-hmm. So now you have 4 grams of sugar per serving.
Right.
And so previously they were having almost
16 to 20 to sometimes 24 grams of sugar.
Okay, got it.
Per serving.
Per serving.
Right. So how do you extend the sweetness? Like if it's ice cream, 4 grams of sugar ain't going to do it. How do you make ice cream with 4 grams of sugar? Kind of hard. So we had to basically do a lot of experimentation. And Tim Harlan got really good at making ice cream. Made a lot of ice cream during this thing. We figured out that we could basically extend the sweetness with a natural sugar that's new. It's relatively new. It's on the market. It's in many foods here in the United States, called allulose.
Yeah, I've tried it before.
And allulose is not sweet enough to be standalone, but it is good enough to extend the sweetness of sugar.
So you take regular sugar and allulose and you sort of get more bang for the buck.
Right. With less metabolic perturbation.
Mm-hmm.
In fact, allulose actually seems to have a good biochemical profile. It actually lowers LDL and raises HDL. So that might be a good thing. We need more work on it. But
how much allulose did you have to use?
Not that much.
Okay, great. Because I often hear some of the same concerns with erythritol about allulose, that a lot of it can cause some gut irritation.
Yeah,
but you didn't have to use that much.
No, we didn't have to use much.
So was that it? Was that the magic formula right there?
Well, that's one of the magic formulas. We had a lot of magic formulas to make this work. The point is that all of this is in the paper, and we very specifically told KDD when we took this job on, when we agreed to this project, that we would be publishing this as a roadmap for other companies to be able to follow suit, because it doesn't matter if KDD does this.
Right.
It's not going to fix the world's problem.
Yeah.
Everyone has to do it. And so they have to know how. And so that this had to become public knowledge. This was not a proprietary issue.
And the honest truth is that I feel like I'm so glad that this individual, KDD, and the company and his whole team, which was a part of it, was so excited, because you do need, people that are key stakeholders to get behind it.
Yeah.
And my personal experience, having friends in the Middle East, family in India also as well, which is not the Middle East, but I find that the craving and the addiction for sugar is even stronger there than it is in the sort of marketplace in the United States. So it's good that you guys publish it for everybody, because who knows, maybe it's an American company that sort of figures out how to get started.
No, this is a huge problem in India, an enormous problem. And the thing is, India has a higher diabetes rate than the United States does.
Yeah.
We have a 10% diabetes rate. India has a 14% diabetes rate, and they're not fat.
They literally add sugar to everything.
That's right. Jaggery.
Yeah, it's crazy. Now, going back to this paper, one of the things that I read in the conclusion that was there is that these ingredients still are going to be raising the price of food.
Yeah.
And that's why you wanted to have an open discussion of who really pays the true cost of food. And one of the challenges today is because ultra-processed food has so much sugar that's added to it, in particular fructose, but also glucose can be a problem too. We are now making people fat, visceral fat, subcutaneous fat, but starting off with this liver fat.
Right.
And then the taxpayer, in the case of some of the sickest in America and the uninsured, and then around the world where people have global access to universal health care in most countries, that the true cost of all this ultra-processed sugary food is being paid by the public and the tax citizens. And we have to change the incentives if we're going to understand the true cost. And now the food doesn't look that expensive relatively for its impact that it has on sickness.
People need to understand that 62% of all healthcare dollars are paid by the federal government.
In Medicare, Medicaid?
All. 62% of healthcare dollars are paid by the federal government.
Mm-hmm.
So when you get sick, that affects me. There's externalities to everything.
Yeah.
People in America have this notion of personal responsibility.
Hey, it's my life. It's my choice.
If you're fat, it's your fault. It's your own damn fault.
And if I want to get fat, that's up to me.
That's
what people are saying.
That's what people say.
Yeah.
The question is that true? The concept of personal responsibility. Where did you first hear of that? Was it in the Declaration of Independence? Was it in the Constitution? Was it in any state legislature constitution? Was it in the Magna Carta? You know, like, who came up with the notion of personal responsibility?
Yeah, I can't even remember.
The tobacco industry. The tobacco industry. Because they were getting killed on the science. And they had to invent another reason for you to smoke. So, if you actually look for the term personal responsibility, 1950 was the very first paper that equated cigarette smoking with lung cancer. The Dahl paper, Richard Dahl. In 1964, the Surgeon General came out with the famous, Surgeon General report, basically equating smoking with lung cancer. Was there any mention of personal responsibility between 1950 and 1964? None. In fact, the tobacco industry was silent on this whole issue till 1964. And then in 1964, they started putting out their own public relations missives in op-eds and ads, etc. And the thing that they said, 3 words that they basically used as their mantra for trying to deal with the problem: assumption of risk. And so assumption of risk, in other words, if you smoke, you're assuming the risk. Okay? And that carried them from 1966 all the way up into 1978. And 1978 was the first time that you ever saw the term personal responsibility anywhere. Didn't exist until 1978. But it was the tobacco industry basically changing their tactic. And the reason they were changing their tactic was because the class action lawsuits were now coming fast and furious. Up to that point, they were all individual lawsuits, and they were able to bat all of them away. 845 separate actions against the tobacco industry, and only 2 of them made it out of Superior Court, and both of those were knocked out on appeal at the appellate level. Okay, so the tobacco industry was batting 1,000, and then the class actions started, and all of a sudden they pivoted again from assumption of risk to personal responsibility. And somehow personal responsibility glommed on to the entire American ethos. Yeah, personal responsibility. Yeah, it's your own damn fault. This was never part of America until the tobacco industry gave it to us. Well, guess what? The sugar industry adopted it too. After that. And so now personal responsibility for obesity, personal responsibility for, what you basically put on your plate. Okay, it's all your own damn fault. Doesn't work. Doesn't work. And it never would work. And the reason is because of the externalities. Because what you consume affects me. Because healthcare is going to hell in a handbasket. Because we will not have healthcare when you'll need it, because it will be gone, because Medicare and Social Security will be broke by the year 2029 because of metabolic syndrome, not because of obesity, because of metabolic syndrome, which is sugar. So this whole concept of personal responsibility, this whole concept of how we're going to deal with the problem, has to be completely rethought. And we have to understand that this is a global problem. This is a problem that government needs to address. This is not something that individuals can fix. This is not something that the food industry will want to fix. Now, the question is, can that work? And the answer is absolutely it can, and we have a model. We actually have a template for how to do this. In 2003, the Blair government in the UK called together all of the food companies in Britain, so Tesco and Marks and Spencer and Waitrose, etc., to a secret meeting. And at that meeting, the Blair government announced hypertension and stroke have gone through the roof in Great Britain. And it's because of the salt in the diet. And we are going to get the salt down. You, food companies, are going to reduce the salt content of each of your offerings by 10% per year over the next 3 years to a final reduction of 30%. And we're not going to tell anybody. All under the wire. Everyone plays, so no one has a competitive disadvantage. And we're not telling the public. We're just going to do it. And we, government, are going to play referee. And they did it. And sure enough, 30% reduction over the course of 3 years. And in 2011, paper came out in BMJ showing a 40% reduction in hypertension and stroke in Great Britain due to this dietary manipulation that no one knew about.
You know, that's a beautiful and benevolent example. Do you ever worry, especially as somebody like you who was saying earlier, you have certain libertarian views on certain subjects?
Certain.
Do you ever worry that that power, when also given to a government and it not being transparent and the public not playing a part in it, that all of a sudden there's other things that the government is now starting to add to either the food system or mandates that they're starting to make, because the government doesn't have a great track record of understanding the science when it comes to areas that are hotly debated. And I think that is one general sort of thing that people, especially that probably listen to this podcast, are like, yikes, that sounds like a good example. But then what happens when the wrong actors have power? Is there ever a concern around that?
I'm always concerned when the wrong actors have power.
Because you give it to one, you can't necessarily take it away from another.
I understand that. I'm always concerned when the wrong actors have power. The question is, who has power now? The wrong actors, the food industry. And what they did was they started adding sugar back in the 1960s because they all went low, because they were told to go low fat. Well, how'd they decide to go low fat? Because the government told them to go low fat. That was a problem, right? Agreed. But how did the government figure that out? Because the sugar industry paid off 2 Harvard School of Public Health nutrition scientists to say so. Fred Stair and Mark Hegsted. Fred Stair was the head of the Department of Nutrition at Harvard, and Mark Hegsted was his deputy, who ended up becoming the head of the USDA. It was a put-up job all along.
So you're basically saying the food industry already has power.
They're already bad actors. And they're already bad actors.
Now, if you look at the case of alcohol and tobacco, it seems to be that in addition to the Surgeon General coming out and making their statement when it comes to tobacco, a big part of the campaign around tobacco that lowered consumption was taxes.
Yeah.
How do you feel about taxes when it comes to processed foods, added sugar, etc.?
I'm for them, but here's why. Here's the difference. I'm for them and I'm against them.
Mm-hmm.
So this is a little complicated.
Yeah.
How can you be for, against, and
let's
against?
Get into the
just
nuance.
like John Kerry. A little flip-flop. No, not at all. I'm not flip-flopping at all. Okay. I'm actually against taxes, but here's why. When you initiate a soda tax or a sugar tax, it's really 3 taxes in one. It's not 1 tax, it's 3. We just don't call the other 2 taxes. First tax is the subsidy, the food subsidy, the sugar subsidy. Because if you're subsidizing one thing, that means you're raising the price on everything else because you have to make book. There's no free lunch. So if you subsidize a product.
Through crop subsidies,
Farm bill, absolutely. So let's get rid of all the subsidies. So the people say, well, if you got rid of all the subsidies, price of food would go sky high. Actually, the Giannini Foundation at UC Berkeley did this exercise several years ago. They modeled what would food look like if we got rid of all, it has to be all the food subsidies, not just the sugar subsidy, but all the food subsidies. And it turns out the price of food would not change except for 2 items, corn and sugar, the things we'd want to go up to try to reduce effective availability. So a subsidy is really a tax. It's a subsidy on one thing, a tax on everything else.
Right.
That's for tax number 1.
Mm-hmm.
Tax number 2, we don't call it a tax. We call it a premium, an insurance premium. Because your employer, which does Mark pay you? He's paying $2,750 a year for obesity-related health care, even though you're not obese. Okay? Every employer is paying $2,750 a year for obesity-related health care, irrespective of whether that individual is obese or not. Well, that employer can't afford that. So that means your salary is lower because of it.
That's why we needed so many young people on Obamacare. Right?
Exactly.
To take care of the primarily older people who are obese.
Correct. Well, that we don't call that a tax, but it is because it's coming out of your pocket. It's called a premium. And then finally, there's the sugar tax or soda tax itself. So that's 3 taxes in one. If you got rid of the subsidies, you could get rid of the other 2. So I'd rather see getting rid of food subsidies. The problem, of course, is that means Congress.
Right.
Because only the Congress can fix that because that's in the Farm Bill.
Yeah.
Okay? If Congress won't act, then the next best thing to do is a sugar or soda tax.
Mm-hmm.
But getting rid of the subsidy is way better. So that's why I'm for it and against it.
Yeah. No, that totally makes sense. Going back to also one of the conversation on subsidies, Sam Katz said one time when I heard him in an interview at this organization summit that I'm part of, Summit Series,
mm-hmm.
He was saying, we give too much credit to subsidies. Subsidies has allowed for all these efficiencies in these big processed food companies.
Yep.
And so it's the efficiencies that, because they're efficient at using corn for this, they're efficient at using, all these major crops that are there. And so to that I say, okay, great. So use the efficiencies and don't have the subsidies towards it, right? So it still goes back to your idea, which is let's not give favorable edge because that's crony capitalism,
right?
Fake capitalism. Let's have everybody sort of fend for themselves.
Well, that would be good.
And let's see, how that would happen.
I'm for the market.
Yeah.
Let the market work. Subsidies distort the market.
Mm-hmm.
Let's get rid of the subsidies. Let the market work. Even the libertarians can get on board with that.
So what is your hope now, zooming out and after you publish the paper and also this Kuwaiti company?
Yep.
If you could provide us any insight, because they're dealing with the realistic aspects of market share, a consumer base that has been addicted. And like you said at the beginning of this podcast, what happens when you go 30 days without sugar? The first 7 days are hell. And imagine that on a population level where people are getting that reduction.
Well,
even though you're not going to zero.
They're not going to zero. We're not getting rid of sugar. That's part of the genius of this.
Is there a phasing in that they're trying out?
Yes. And they're not telling the public.
Will there be an increased price that people will have to pay potentially?
No.
And so is that the company eating the price, or is it they figured it out?
For the moment, they're eating the price.
Do you have a general sense of how much more it costs?
No, I don't. Not yet. They've re-engineered 10% of their portfolio, 18 items.
Got it.
And 3 of them are on the market in Kuwait today.
So extrapolating this now to something I brought up to you earlier, and just a heads up, we probably about 15 minutes to 6, and I know you have a time constraint. When you look at what Michelle Obama is trying to do, and I believe that she's coming from, regardless of people, I've had Callie Means on this podcast before,
right?
And he has a lot of very strong opinions, and he gets me
Callie's
fired up.
Callie's absolutely right.
Right?
I love Callie. He is wonderful, and he worked in
he knows
system.
the behind the scenes. He sees the system. He knows the food industry will use racism and any other tool that's available to push this whole personal responsibility angle.
And I watched it.
So he would say on Twitter that there's no healthy amount of added sugar. And I'm trying to hold that sort of understanding of things with this other side, which is, Dr. Robert Lustig, who says that I'm not a purist, I'm a realist. And so I understand that people are going to still be addicted to sugar. And so in the case of Michelle Obama, and I don't know the total carbohydrate amount, I can pull it up here in a second, but I think it's like 10% added sugar that's inside of that, right? Yeah. And so give us your nuanced thoughts on something like that approach with her new drink company. I think you said it's called Plessy.
Plessy. I am not for it.
You're not for it?
I am not for it. No.
Even though you feel that people have to make changes in strides?
I think that it's a interesting concept, but a lousy execution. I don't see how this is going to actually change the dynamic, and I don't see how it's going to change the disease burden of children and or the rest of America. Mm-hmm. I don't see it.
Even if their goal is to get people off of sweetened soft drinks, and I'm not saying I know the right answer.
Well,
right?
They're not, because they're using artificial sweeteners, which have their own problems. Now, allulose might have problems, but no one's found them yet. So I'm betting that because of allulose's structure, because of its kinetics, because of its pharmacodynamics that we do know about, and because of the empiric studies that have been done, that is a better sweetener extender. Plessy's not using that. Plessy's using erythritol and other
I think that they're using some stevia and monk fruit as part of it. Right. I don't know if I'm only looking at one nutritional label.
Right. Just remember that you put something sweet on the tongue. Mm-hmm. Message goes tongue to brain, sugar's coming. Message goes brain to pancreas, sugar's coming, release the insulin. Mm-hmm. But then the sugar never comes because it was a diet sweetener. The pancreas still releases the insulin. We have the data to show that. And that's true for stevia and monk fruit too. Does not seem to be true for allulose. Mm-hmm. So I don't know whether or not this will be the right formulation. We need data, we need science to tell us. Thus far, I haven't seen it.
Yeah.
So I think it's a little bit ill-advised.
And I just want to say for the record, I might have gotten the breakdown incorrect because I'm looking at their website and it says no added sugar.
Right.
It says no added sugar, 2 grams of fiber, real fruit juice. Again, we're just using this
real fruit juice means
fructose.
Sugar. Yeah.
And the total amount of carbohydrates is 9 grams, 2 grams of dietary fiber, and total sugars is 6 grams. Mm-hmm. I look at this and I would say that, again, I have no connection with them. I have no connection with the campaign and other things. I'm generally an independent when it comes to politics, socially leaning liberal, fiscally leaning, maybe probably conservative. And I have a lot of nuanced thoughts about a lot of things.
Whatever happened to the social liberal fiscal conservatives? What happened to them?
I don't know.
That's me too.
Yeah. So I would say, naturally anybody who's a public figure like Michelle Obama is going to get a lot of criticism. And I generally think that they expected that. She has a lot of advisors. And at the end of the day, she probably has a bigger why that's driving her. And then let the chips fall where they may, and she can get a chance to see. But I see a lot of sort of, this is healthier than a lot of, I want to say this for just the record, this is healthier than a lot of acai bowls that I see people giving to kids. Yeah. It's healthier than a lot of green juices that have a ton of sugar that's added to them. People have green juice that has more, again, I don't want everybody drinking this Plessy drink that's out there. I like the discussion, right? And I think our audience also likes the discussion too, because so much, once you get excited about changing your own health, once you get excited about significantly reducing sugar, you naturally think about how we can make a difference in society as well too, which is why a lot of people are thinking about this question.
Unfortunately, Michelle Obama has a lousy track record in this.
Mm.
You know, she started Let's Move in 2010. And if you go on YouTube right now, you can see the very first speech she gave to the Grocery Manufacturers Association, the GMA, in 2010. She was in a pink dress, sleeveless, of course. And she pointed her finger directly at them and said, "This is your problem, and you have to fix it. And you have to get the sugar out of kids' diets." She never said it again.
Because she got so much criticism.
From her own administration.
From our own administration, but I also saw a lot of conservatives, again, not to make this a left and right.
Because it's
how
about
dare
calories.
you, nanny state, this is Michelle Obama. Probably a lot of that sort of washed in sort of who does she think she is.
And because it was calories and personal responsibility.
Yeah.
Okay. The point is, by 2012, Michelle Obama was only talking about exercise.
Yeah.
Let's Move became Let's Move. So I'm going to withhold judgment.
Yeah. So we'll watch and we'll wait and see. But I appreciate you at least getting into the dialogue. Again, I'm watching just like everybody else and people are having a conversation. At the end of the day, a lot of people have said, you know, change doesn't start in Congress, and you could probably add former administration to that as well. Right. It starts in the public. It starts with podcasts. It starts with people changing what media they're focused on, and they're tuning off the TV and they're turning on something else, and they're getting access to different information.
Dhru, why do you think I'm here?
Which I super appreciate, right? Let's leave people with a couple action items before you depart. Okay.
Eat real food.
Eat real food.
Eat real food. Food that came out of the ground or animals that ate the food that came out of the ground. That's a great way to start.
And if somebody was significantly cutting added sugar out of their diet, right? And they're pulling back from rolling the dice of what can happen when you have a lot of sugar in your diet, and they're getting away from ultra processed foods, and hopefully they're exercising as well too.
Right.
What would they typically see also on their blood work at, let's say, like 30 days and 90 days?
The most important test that their doctor can draw on them, they're not drawing. It's a fasting insulin level.
That's one of the top tests. That's literally one of the top tests. The top test.
The top test. You're a levels advisor. I'm a levels advisor. I help them construct Labs 2.0. And Labs 2.0 is 5 tests: fasting insulin, hemoglobin A1C, uric acid, serum triglycerides, and ApoB. And the reason is because all of them tell you about mitochondrial dysfunction. They don't tell you about obesity. They tell you about mitochondrial dysfunction. Fasting insulin is the single most important test to look for mitochondrial dysfunction. If your fasting insulin is above 10, you have it. If your fasting insulin is above 15, you have it bad. That's a great way to start. Now,
and optimal, would you say, is 5 or less?
5 or less is fantastic. If you're a marathon runner, you have a 2.
Yeah.
Okay.
I'm about a 3.
Oh, well, why am I surprised? Of course you are. The point is that the American Diabetes Association tells doctors don't draw fasting insulin.
Why is that?
2 reasons. First, fasting insulin levels are not standardized across platforms. So different assays give
So you could
results.
run at Quest, and it could be different than running it at another company.
Right. And the reason is because some assays pick up proinsulin in the insulin assay. Proinsulin is a precursor to insulin. When your pancreas is stressed and it's trying to put out everything it can, it will put out proinsulin too. And proinsulin will be picked up in the insulin assay. So you're not actually measuring insulin. That's true. I don't disagree with that. Point is, it's high. That's what matters. And if it's high, you got a problem.
Right.
So draw it anyway.
Draw it anyway. It's a cheap test.
And then you can use that number to follow whether the patient gets better. You have a benchmark for whether the patient gets better. So that's specious reason number 1.
Yeah. One actionable thing everybody can do today, go to your doctor, ask nicely, and get this test. It's not that expensive. Right. Tell them why you care about that. Right. Give them a copy of your book if they're open to it.
That's a good idea.
Right?
The second reason the ADA says don't draw it is because fasting insulin levels do not correlate with obesity. That's correct. They correlate with metabolic health.
Right. You can have those skinny TOFI people who still have a high fasting insulin,
there you go,
but are not by BMI standards overweight.
So both reasons wrong. Get the fasting insulin.
It almost feels like just an entire organization that's main goal is to drive a national awareness around fasting insulin would be a good idea.
Hey, let's start it.
Hey, I'm game. I'll put some money towards that. Let's go. Amazing. Eat real food.
Eat real food, get a fasting insulin, okay, and exercise and sleep.
Yeah.
I mean, sleep's a big problem in this country.
It's huge.
Okay. And it's not just because you're fat.
Yeah.
It's because of the thing in your pocket.
Too much screen time, phone distraction.
Too much screen time. Yep.
Yeah. Take your sleep seriously.
Yeah. Take your sleep seriously. Take your sleep as seriously as you do your diet.
Yeah. Robert, this has been fantastic. The amount of topics we covered has been incredible, and I could only do this with you in person. So thank you,
of course,
for making time.
Dhru, my pleasure. Anytime. I am, just delighted that you're on this wagon with this juggernaut with us.
Well, I stand on the shoulders of giants like yourself. Thank you again. Thank you for your work, and thank you for coming on the podcast.
My pleasure.
Hey, YouTube! If you enjoyed what you just saw, keep watching for more great content on how to improve your brain and your life.
Not one of those diseases was a child's disease. And now they're all child diseases. We never saw type 2 diabetes in a child before. And now